Authors: Nat Geo Wild Geographic Society. Lucy Daniels, LD Teacher Consultant. Peter Milero, PhD. Consultant Safety, Sandra West, PhD. Reading: Elizabeth Barbish. Conservation and Native Interaction of Life. Living on Earth. Populations, habitats. Populations, competition, population size, measuring population, limiting factor, sample count, change in population, moving around. Visualizing population growth, beginning growth. During the first population growth is slow because there are few adults to produce young. As the population grows, so does the number of breeding adults. When a species enters an ecosystem that has abundant food, water, and other resources, its population can flourish. Beginning with a few organisms, the population increases until the number of organisms and available resources are in balance. At that point, population growth slows or stops. A graph of these changes over time produces an S-curve, as shown for the coyotes. Interaction with communities. Obtaining energy. Just as a car engine needs a supply of gasoline, living organisms need a supply of energy. The energy that fuels life. The energy that fuels most life on Earth comes from the sun. Some organisms use the sun energy to create energy-rich molecules through the process of photosynthesis. The energy-rich molecule, usually sugar, through the process of photosynthesis. The energy-rich molecules, usually sugar, serve as food. They are made up of different combinations of carbon, hydrogen, and oxygen atoms. Of these molecules of and oxygen atoms, energy is stored in the chemical bonds that hold the top of these molecules together. When the molecules break apart, for example, during digestion, the energy in the chemical bond is released to fuel life processes. Producers. Organisms that use an outside energy source, like the sun, to make energy-rich molecules are called producers. Most producers contain chlorophyll, chlorophyll, a chemical that is required for photosynthesis, as shown in figure 12. Green plants are producers. Some producers do not contain chlorophyll, then they do not use chlorophyll from the sun. Instead, they make energy-rich molecule through a process called chemosynthesis. The organisms can be found near volcanic vents on the ocean floor. Inorganic molecules in the water provide this energy source for chemosynthesis. Green plants, including grasses that surround ponds, are producers. The ponds also contain many other producers, including microscopic organisms like euglena and simple plant organisms called algae. Consumers. Consumers include herbivore, carnivore, omnivore, decomposers. Consumers are organisms that cannot make their own energy-rich molecule. Consumers obtain energy by eating other organisms. Herbivores are the vegetarian of the world. They include rabbits, deer, and other plant eaters. Carnivore, or animals that eat other animals. Frogs and spiders are carnivore that eat insects. Omnivore, including pig and human, eat mostly plants and animals. Decomposers, including fungi, bacteria, help an earthworm consume waste and dead organisms. Decomposers help recycle one's living matter by breaking it down into simple energy substances. These substances might serve as food for decomposers, be absorbed by plant roots, or be consumed by other organisms. Food chain. Ecology includes the study of how organisms depend on each other for food. A food chain is a simple model of the feeding relationship in an ecosystem. For example, shrubs are food for deer, and deer are food for mountain lion. What food chain would include you? Glucose is a nutrient molecule produced during photosynthesis. Look at the chemical structure of glucose and draw it out in your journal. Symbiotic relationship. Not all relationships among organisms include food. Many organisms live together and share resources in other ways. Any close relationship between species is called symbiosis. Lynching are a result of mutualism. Clownfish and sea anemones once have a commercial relationship. Mutualism. You may have noticed crustaceans growing on fences, trees, or rocks. Lynchings are those shown in figure 15a. They are made up of an algae or cyanobacterium that lives within the tissue or a fungus. Through photosynthesis, the cyanobacterium or algae supplies energy to itself and the fungus. The fungus provides a protected space in which the cyanobacterium or algae can live. Both organisms benefit from this association. A symbiotic relationship in which both species benefit is called mutualism. Commercialism. If you ever visited a marine aquarium, you might have seen the ocean organisms. The creature with gently waving tube-like tentacles in a sea anemone. The tentacles contain mite poison. Animals use their tentacles to capture shrimps, fish, and other small animals to eat. The stripped-down clownfish can swim among the tentacles without being harmed. The animal tentacles protect the clownfish from predators. In this relationship, the clownfish benefits, but the sea animal is not helped or hurt. A symbiotic relationship in which one organism benefits and the other is not affected is called commercialism. Parasitism. Pets, cats, dog sometimes have to be treated for worm. Roundworm like the ones shown in figure 15C are common in puppies. This roundworm attaches itself to the inside of the puppy intestine and feed on nutrients in the puppy's blood. The puppy may have abdominal pain, bloating, and diarrhea. If the infection is severe, the puppy might die. A symbiotic relationship in which one organism benefits but the other is harmed is called parasitism. Niche. One habitat might contain hundreds or even thousands of species. Look at the rotting log habitats shown in figure 16. A rotting log in a forest can be home to many species of insects, including termites that eat decaying wood and ants that feeds on termites. Other species that live on or under the rotting log include millipedes, centipedes, spiders, and worms. You might think that competition for resources would make it impossible for so many species to live in the same habitat. However, each species has different requirements for its survival. Now, as a result, each species has its own niche. A niche refers to how an organism survives, how to obtain food and shelter, how it finds mates and care for its young, and how it avoids danger. Special adaptations that improve survivors are often parts of an organism niche. Milkweed plants contain a poison that prevents many insects from feeding on them. Monarch butterfly, caterpillar have an adaptation that allows them to eat milk, to eat milkweed. Monarchs can take advantages of the food resources that other species cannot use. The milkweed poison also helps protect monarchs from predators. When the caterpillar eats milkweed, they become slightly poisonous. Birds avoid eating monarchs because they learn that the caterpillars and adult butterflies have an awful taste and makes them sick. Earth integration. The poison in milkweed is similar to the drug digitalis. Small amounts of digitalis are used to treat heart ailments in humans, but it is poisonous in large doses. Look up digitalis and explain in your science journal how it affects human body. Different adaptations enable each species living in this rotting log to have its own niche. Termites eat wood. A. They make tunnel inside the log. B. Millipede feeds on plant matter and finds shelter beneath the log. C. Wolf spiders capture insects living in and around the log. Predators and prey. When you think of survival in the wild, You might imagine an antelope running away from a lion. Niche includes, like the one shown in figure 17, our consumers that eat other consumers. The prey is the organism. The presence of predators. The prey is the organism that is captured by the predator. The presence of predators usually increases the number of different species that can live in an ecosystem. Predators limit the size of prey population. As a result, food and other resources are less likely to be scarce, and competitions between species is reduced. The alligator is a predator. The turtle is a prey. Cooperation. Individual organisms often cooperate in ways that improve survival. For example, a white-tailed deer that detects the presence of wolves or coyotes will alert the other deer in the herd. Many insects, such as ants and honeybees, will live in social groups. Different individuals perform different tasks, and they are required for different times. Soldiers' ants protect workers that go out of their nest to gather food. Workers' ants feed and care for ant larvae that hatch from eggs laid by the queen. And survivors are part of a person's niche. Feeding habitat of plunaria. Population growth in fruit flies. Reviewing man idea. The non-living environment. Could you write a story about what will happen if the sun stops shining? Most lives on earth depend on the sun energy. Most life on earth depends on the sun energy. In this chapter, you will learn how organisms called producers use energy to make food, and how other organisms called consumers still take in that food. You also read about cycles in nature such as carbon and nitrogen cycles, and many other non-living things that affect your life. Abiotic factors, environmental factors. Living organisms depend on one another for food and shelter. The leaves of plants provide food and a home for grasshoppers, caterpillars, and other insects. Many birds depend on insects for food. Dead plants and animals decay part of the soil. The features of environments that are alive or the one's life are called biotic factors. The term biotic means living thing. Biotic factors are not the only environment that are important to life. Most plants cannot grow without sunlight. Air, water, and soil. Animals cannot survive without air, water, the warmth that sunlight provides. The non-living physical features of the environment are called abiotic factors. The prefix "a" means not. The term abiotic means non-living. Abiotic factors include air, water, soil, sun, temperature, and climate. The biotic factors. The biotic factor the biotic factors include air, water, soil, sunlight, temperature, and climate. The abiotic factors often determine which kind of organisms can live them. For example, water is an important abiotic factor in the environment, as shown in Figure 1. Air. Air is invincible and plentiful, so it is easily overlooked as an abiotic factor of the environment. The air that surrounds Earth is called atmosphere. The air contains 78% nitrogen, 21% oxygen, 0.94% argon, 0.03% nitrogen, carbon dioxide, and trace amounts of other gases. Some of these gases provide substances that support life. Carbon dioxide. CO2 is required for photosynthesis. Photosynthesis is a series of chemical reactions using CO2, water, energy from sunlight To produce sugar molecule, organisms like plants that use photosynthesis are called producers because they produce their own food. During photosynthesis, oxygen is released from the atmosphere. When a candle burns, oxygen from the air chemically combines with the molecule of candle wax. Chemical energy stored in the wax is converted and released as heat and light energy. In a similar way, cell uses oxygen to release the chemical energy stored in sugar molecule. This process is called respiration. Through respiration, cells obtain the energy needed for all life processes. Air-breathing animals are the only organisms that need oxygen. Plants, some bacteria, algae, fish, and most other organisms also need oxygen for respiration. Water. Water is an essential part of life. It is a major ingredient of the fluid inside the cell of all organisms. In fact, most organisms are 50% to 95% water. Respiration, digestion, photosynthesis, and many other important life processes can take place only in the presence of water. As figure 2 shows, environments that have plenty of water usually support a greater diversity of and a larger number of organisms and environments that have little water. A. Water is an important abiotic factor in deserts and rainforests. A. Life in deserts is limited to species that can survive for a long period without water. B. Thousands of species can live in lush rainforests without rain almost every day. Soil. Soil is a mixture of mineral and rock particles. The remains of dead organisms, water, and air. It is the topmost layer of the earth crust, and it supports plant growth. Soil is formed in parts of rock that have broken down into tiny particles. Soil is considered an abiotic factor because most of it is made up of non-living rock and mineral particles. However, soil also contains living organisms and the decaying remains of dead organisms. Soil include bacteria, fungus, insects, and worms. The decaying matter found in soil is called humus. The type of soil present in a region has an important influence on the kind of plant life that grows there. Sunlight. All life requires energy, and sunlight is the source of all energy. During photosynthesis, producers convert light energy into chemical energy that is stored in sugar molecules. Consumers are organisms that cannot make their own food. Energy is passed to consumers when they eat producers or other consumers, as shown in figure 3. Photosynthesis cannot take place if light is never available. Photosynthesis requires light. A. Little sunlight reaches the shady forest floor, so plant growth beneath trees is limited. Sunlight does not reach into deep lake or ocean water. Photosynthesis can take place only in shallow water or less surface. How the fish that live at the bottom of the ocean obtain energy? Temperature. Sunlight supplies life on earth with light energy for photosynthesis. And heat energy for warmth. Most organisms can survive only if their body temperature stay within the range of 0 OC. The penguins has a thick layer of fat to hold it that keep the bird from freezing. These emperor's penguins huddle together for added warmth, and they are adapted for survival in freezing Antarctic. Camels can survive the hot temperature of the Arabian desert because their bodies are adapted for staying cool. The temperature of a region depends on the land latitude and elevation. Elevation. If you have climbed or driven up a mountain, you probably noticed a region elevation or distance gets cooler as you went higher. A region elevation or distance above sea level affects its temperature. Climate. Climate refers to an area average weather condition over time. including temperature, rainfall, or other precipitation, the wind. For the majority of living things, temperature and precipitation are the two most important components to climate. The average temperature and rainfall in an area influences the type of life found there. Suppose a region has an average temperature of 25 degrees Celsius and receive an average of less than 25 degrees every year. It is likely to be the home of cactus plants and other desert life. A region with similar temperature that receive more than 300 centimeters of rain every year is probably a tropical rainforest. Winds. Heat energy from sun only determines temperature, but also responsible for the wind. The air is made up of molecules of gas. As the temperature increases, the molecules spread further apart. As a result, warm air is lighter than cold air. Air sinks below warmer air and pushes it upward, as shown in figure 7. This motion creates air currents that are called wind. Integration. Gravity pulls the atmosphere towards the earth, presses it down on the air above it, and presses it down on the air below it. Explain why air at sea level is thicker than air at the top of a mountain. Wind are created when sunlight hits some portions of Earth's surface more than others. In areas that receive some heat, the air becomes warmer. Cold air sinks beneath the warm air, forcing the air upward. The rain shadow effect. The presence of mountain can affect rainfall pattern. Wind blowing towards one side of the mountain is forced upwards by the mountain shape. As the air nears the top of the mountain, it cools. When air cools, the moisture contains in it falls as rain or snow. By the time the cool air crosses over the top of the mountain, it has lost most of the moisture. The other side of the mountain range receive much less precipitation. It is not uncommon to find large forests on one side of the mountain range and desert on the other side. Humus farm. Soil contains abiotic factors, including rock, particles, and materials. Soil also contains biotic factors such as bacteria, mold, fungi, worm, insects, and decayed organisms. The crumbly dark brown soil found in garden or forest contains a high percentage of humus. Humus is formed primarily from decayed remains of plants, animal, and animal droppings. It added essential nutrients to the soil, including nitrogen. Cycle in nature. The cycle of matters. Imagine an aquarium containing water, fish, snail, plants, algae, and bacteria. This tank is sealed so that only light can enter. The food, water, and air we cannot add. Will the organisms in the environment survive? Through photosynthesis, plants and algae produce their own food. Through that same photosynthesis, they also supply oxygen to the tank. Fish and snail take in oxygen and eat plants and algae. Waste from fish and snail fertilize plants and algae. Organisms that die are decomposed by the bacteria. The organisms in this closed environment can survive because the materials are recycled. A constant supply of light energy is the only requirement. Each biosphere also contains a fixed amount of water, carbon, nitrogen, oxygen, and other minerals required for life. These materials cycle through the environment and are reused by different organisms. Water cycle. If you leave a glass of water on a sunny windowsill, the water will disappear. It evaporates. Evaporation takes place when liquid water changes into water vapor, which is a gas, and enters the atmosphere as shown in figure 9. Water evaporates from the surface of lakes, streams, puddles, and oceans. Water vapor enters the atmosphere from plant leaves. In a process known as transpiration. Animals release water vapor into the air when they exhale. Water also returns to the environment from animal waste. Condensation. Water vapor that has been released into the atmosphere eventually comes into contact with cold air. The temperature of the water vapor drops. Over time, the water vapor cools enough to change back into liquid water. Water vapor condenses on particles of dust in the air. Over time, the vapor water is cool enough to change back into liquid water. The process of changing from a gas to a liquid is called condensation. Water vapor condenses on particles of air. Of particles of dust in the air, forming tiny droplets. At first, the droplets clump together to form cloud. When they become large and heavy enough, they fall to the ground as rain or other precipitation. As the diagram in figure 4 shows, the water cycle is a model that describes how Earth to the atmosphere and back to the surface again. Water use. Table 1 gives data on the amount of water people take from reservoirs rivers, and lakes for use in the household. Businesses, agriculture, and power production. These actions can reduce the amount of water that evaporates into the atmosphere by limiting the amount of water available to plants and animals. The water cycle involves evaporation, condensation, precipitation. Water molecules can follow several pathways through the water cycle. How many water cycle pathways can you identify from this? Nitrogen cycle. The element nitrogen is important in all living things. Nitrogen is a necessary ingredient of protein. Protein are required for the life processes that take place in the cell of all organisms. Although nitrogen is the most plentiful gas in the atmosphere, most organisms cannot use nitrogen directly from the air. Plants need nitrogen that has been combined with other elements to form nitrogen compound. Through nitrogen fixation, because some types of soil bacteria can form the nitrogen compounds that the plant need. Plants absorb this nitrogen compound in their roots. Animals obtain the nitrogen they need by eating plants or other animals. When dead organisms decay, the nitrogen in their body returns to the soil or to the atmosphere. This transfer of nitrogen from the atmosphere to the soil, to living organisms, and back to the atmosphere is called nitrogen cycle. During nitrogen cycle, nitrogen gas from the atmosphere is converted to a soil compound that plants can use. Nitrogen gas is changed into usable compound by lightning or by nitrogen fixing bacteria that lives on the roots of certain plants. Animals can eat plants. Animal waste returns some nitrogen compound to the soil. Animals and plants die and decompose, releasing nitrogen compound back into the soil. Plants use nitrogen compound to build cells. Nitrogen fixation is important to plant growth. A. Soya beans can help restore nitrogen to the soil. B. The swollen nodules on the roots of the soya beans plant contain colonies of nitrogen fixing bacteria. C. The bacteria depend on the plant for food. The plant depends on the bacteria to form the nitrogen compound to the plant need. Soil nitrogen. Human activities can affect the part of the nitrogen cycle that takes place in the soil. If a farmer grows a crop, such as a corn or wheat, most of the plant materials is taken away when the crop is harvested. The plants are not left in the field to decay and return their nitrogen compound to the soil. If these nitrogen compounds are not replaced, the soil could become infertile. You might have noticed that adding fertilizer to the soil can make plants grow greener. Bushier or taller. Most fertilizers contain the kind of nitrogen compound that plants need for growth. Fertilizers. Fertilizers can be used to replace soil nitrogen in a crop field, lawns, and garden. Compost and animal manure also contain nitrogen compound that plants can use. They also can be added to the soil to replace soil nitrogen. Compost. Another method farmers use to replace soil nitrogen is to grow nitrogen fixing crops. Most nitrogen fixing bacteria live on in the roots of certain plants. Some plants, such as peas, clovers, and grain, include the soybean soil shown in figure 12 have roots with swollen models that contain nitrogen fixing bacteria. These bacteria supply nitrogen to the soybean plants and add nitrogen compounds to the soil. Visualizing the carbon cycle. Carbon in the form of different kinds of carbon containing modules. Carbon moves through an endless cycle. It begins when the plants and algae remove from carbon from the environment during photosynthesis. The carbon returns to the atmosphere via several carbon action pathways. A. The air contains carbon in the form of carbon dioxide gas. Plants and algae use carbon dioxide to make sugar, which are energy-rich carbon-containing compounds. B. Organisms break down sugar molecules made by plants and algae to obtain energy for life and growth. Carbon dioxide is released as a waste. C. Burning fossil fuel and wood release carbon dioxide into the atmosphere. D. When organisms die, their carbon-containing molecule become part of the soil. The molecules are broken down by fungi, bacteria, and other decomposers. During this decay process, carbon dioxide is released into the air. E. Under certain conditions, the remains of some dead organisms may gradually change into fossil fuel, such as coal, gas, oil. These rich compounds are energy rich. The carbon cycle. The carbon atoms are found in the molecule that makes up living organisms. Carbon is an important part of soil humus. Which is formed when the dead organisms decay, and it is found in the atmosphere as carbon dioxide gas. CO2. The carbon cycle describes how carbon molecule moves between the living and the non-living world. The carbon cycle begins when the producers remove CO2 from the air during photosynthesis. They use CO2, water, and sunlight to produce energy-rich sugar molecule. Energy is released from these molecules during respiration, the chemical process that provides energy for cell. Respiration uses oxygen and release CO2. Photosynthesis uses CO2 and release oxygen. These two processes help recycle carbon on Earth. Human activities also release CO2, which is carbon dioxide, into the atmosphere. Fossil fuels such as gasoline, coal, and heating oil are the remains of organisms that lived millions of years ago. These fuels are made up of energy-rich, carbon-based molecules. But when people burn these fuels, carbon dioxide is released into the atmosphere as a waste product. People also use wood for building and for fuel. Trees that are harvested for these purposes no longer remove carbon dioxide from the atmosphere during photosynthesis. The amount of CO2 in the atmosphere is increasing. Extra CO2 could trap more heat from the sun and cause average temperature to rise on Earth. Research. Visit the glencoe.com for the chemical equation that describe the photosynthesis and respiration. Energy flow. Converting energy. All living things are made up of matter, and all living things need energy. Matter and energy move through the natural world in different ways. Matter can be recycled over and over again. The recycling of matter requires energy. The conversion of energy is important to all life on Earth. Photosynthesis. During photosynthesis, producers convert light energy into the chemical energy in sugar molecules. Some of these sugar molecules are broken down as energy is needed. Others are used to build complex carbohydrates, molecules that become part of the consumer body. Fat and protein also contain stored energy. Chemosynthesis. Chemical is in the water that flows from hydrothermal veins, provide bacteria with a source of energy. B. The bacteria producers use this energy to make nutrients through the process of chemosynthesis. Consumers, such as tube feeds on the bacteria. Chemosynthesis. Not all producers rely on light for energy. During the 1970s, scientists exploring the ocean floor were amazed to find communities teeming with life. These communities were at a depth of almost 3.2 kilometers and living in total darkness. They were found near powerful hydrothermal veins like the one shown. Hydrothermal veins. A hydrothermal vein is a deep crack in the ocean floor through which the heat of molten magma can escape. The water from hydrothermal veins is extremely hot. Because from contact with molten rocks that lies deep in the earth crust. Because no sunlight reaches this deep ocean region, plants or algae cannot grow here. How do the organisms living in this community obtain energy? Scientists learned that the hot water contains nutrients such as sulfur molecules that bacteria use to produce their own food. The production of energy-rich nutrient molecule from chemical is called chemosynthesis. Consumers living in the hydrothermal veins communities rely on chemosynthetic material for nutrients and energy. Chemosynthesis and photosynthesis allows producers to make their own energy-rich molecule. Energy transfer. Energy can be transferred from one form to another. It also can be transferred from one organism to another. Consumers cannot make their own food. Instead, they obtain energy by eating producers or other consumers. This way, energy stored in a molecule of one organism is transferred to another organism. At that time, the matter that make up those molecules is transferred from one organism to another. Throughout nature, energy and matter move from organism to organism when one organism becomes food for another organism. Food chain. A food chain is a way of showing how matter and energy pass food from one organism to another. Producers, plants, algae, and other organisms that are capable of photosynthesis or chemosynthesis are always the first step in a food chain. Animals that consume producers, such as herbivore, are the second step. Carnivore and omnivore. Animals that eat other consumers are the third and higher steps of the chain. One example of food chain is shown. The first hydrothermal vent community discovered was found along Galapagos Reef Zone, a reef zone formed where two plates of earth crust are spreading apart. In this food chain, grasses are producers, mammoths are herbivore and eat the grass, and the grizzly bear are consumers that eat mammoths. The arrow shows the direction of which the matter and energy flow. Food web. A forest community includes many feeding relationships. Yes, these relationships can be too complex to show with a food chain. For example, grizzly bears eat many different organisms, including berries, insects, chipmunk, and fish. Berries are eaten by bears, birds, insects, and other animals. A bear carcass might be eaten by a wolf birth, or insect. Or a food web is a model that shows all the possible feeding relationships among the organisms in a community. A food web is made up of many different food chains, as shown in figure 16 below. Compared to a food chain, a food web provides a more complete model for the feeding relationship in a community. Decomposers, grass, insects. An insect feed on grass or berries. Then a grouse feeds on the insects and also on the berries. Energy pyramids. Food chain usually have at least 3 links, but rarely more than 5. This limit exists because the amount of available energy as you move from one level to the next in a food chain. Imagine a grass plant that absorbs energy from the sun. The plant uses some of this energy to grow and produce seeds. Some of the energy is stored in the seed. Compared to a food chain, the food web is more detailed. Available energy. When a mouse eats grass seeds, energy stored in the seed is transferred to the mouse. However, most of the energy the plant absorbed from the sun was used for the plant to grow. Much less energy is stored in the seed eaten by the mouse. The mouse uses much of the energy remaining in the seed for its own life processes, including respiration, digestion, and growth. A hawk that hits the mouse obtains even less energy. The same thing happens at every feeding level of food, at every feeding level of food chain. The amount of available energy is reduced from one feeding level to another. An energy pyramid. Like the one in figure 17 shows, the amount of energy available at each feeding level in an ecosystem. The bottom layer of the pyramid, which represents all of the producers, is the first feeding level. Because it contains the most energy and the largest number of organisms. As you move up the pyramid, each level becomes smaller. Only about 10% of the energy available at each feeding level of an energy pyramid is transferred to the next higher level. This energy pyramid shows that each feeding level contains less energy than the energy below it. Where does the mass of a plant comes from? An enormous oak trees start out as a tiny acorn. The acorn sprouts in dark, moist soil. Root goes down through the soil. Its stems and leaves grow up towards the light and air. Year after year, the tree grows taller. Its trunk grows thicker and its roots grows deeper. It becomes a towering oak that produces thousands of acorns of its own. An oak tree has much more mass than an acorn. Where does this mass come from? The soil, the air. In this activity, you'll find that by conducting an experiment with reddish plants, what you will investigate: does all the matter in a reddish plant come from the soil? Science statistics, extreme climate. Did you know the greatest snowfall in 1 year occurred at Mount Baker in Washington State? Approximately 2,896 centimeters of snow fell on Mount Baker during the 1998 to 1999 12-month snowfall season. That is enough snow to bury an 8-story building. Do you know The hottest climate in the United States is found in Death Valley, California. In July 1913, Death Valley reached approximately 57 degrees Celsius. This is the hottest officially recognized temperature on Earth. As a comparison, a comfortable room temperature is about 20 degrees Celsius. The record for the lowest temperature was set in Antarctica in 1983. The temperature was a frigid minus 89 degrees Celsius. As a comparison, the temperature of your freezer at home is about minus 15 degrees Celsius. Connecting to mathematics. The fastest tornado wind have been measured at a speed of 512 kilometers per hour. That is faster than the blade of some helicopter. Which can rotate at about 450 kilometers per hour. Do the math. Reviewing main ideas. Visualizing main ideas. Ecosystem. During the summer of 2000, wildfire burned out of control in Montana and other western states. Can this Montana hillside recover from the forest fire? Can the animals that lived here before the fire adapt to the change of the environment? How is the forest in this picture different from the rainforest in South Africa? In this chapter, you will learn about the different ecosystems that exist on Earth. The plants growing in your classroom or your home may not look the same that you find growing outside. Where do indoor plants come from? Many indoor plants don't grow well outside. In most North American climates, how ecosystem change. Ecological succession. What will happen if the lawn at your home were never cut? The grass will get longer, and soon it will look like a meadow. Later, larger plants will grow from seeds brought to the area by animals or wind. Then, trees might sprout. In fact, in 20 years or more or less, you wouldn't be able to tell that the land was once a mud lawn. An ecologist can tell you what type of ecosystem your lawn would become. If it will become a forest, they can tell you how long it will take. If it will become a forest, they can tell you how long it can take and predict the type of trees that will grow there. Succession refers to the normal, gradual changes that occur in the type of species that live in an area. Succession occurs differently in different places around the world. Primary succession. As lava flows from the mouth of a volcano, it is so hot that it destroys everything in its path. When it cools, lava forms a new land, composed of rock. It is hard to imagine that this land eventually would become a forest or grassland someday. The process of succession that begins in a place without any soil is called primary succession. Why? It starts with the arrival of living things, such as lynchings. These living things, called pioneer species, do not need soil to survive. They survive drought, extreme cold, and other harsh conditions, and start the soil building process. Open area that are not maintained will become overgrown with grasses and shrubs as succession begins. New soil. During primary succession, shown in figure 2, soil begins to form as lynchings and the forces of weather and erosion helps break down rocks into smaller pieces. When lynchings die, they decay, adding small amounts of organic matter to the rock. Plants decay, plants such as mosses and ferns can grow in this new soil. Eventually, this plant die adding more organic material. The soil layer thickens and grasses, white flower, and other plants begin to take over. When these plants die, they add more nutrients to the soil. This buildup is enough to support the growth of scrub and trees. Otherwise, insects, small birds, and mammals have begun to move in. What was once bare rock now supports a variety of life. Secondary successions. What happens when a fire such as the one before destroys a forest, or when a building is torn down in a city after a forest fire? Not much is left except dead trees and ash-covered soils. After the rubble of a building is removed, all that remains is a bare soil. However, these places do not remain lifeless for long. The soil already contains the seed of weeds, grasses, and trees. More seeds are carried to the area by wind and bird. Other wildlife may move in. Succession that begins in a place that already has soil and was once the home of living organisms is called secondary succession. Because soil already present, secondary successions, because soil is already present, because secondary succession occurs faster and has different pioneer species than primary successions. Lynching like these in Colorado are fragile and may take years to grow. They often cling to bare rocks where many other organisms can't survive. Visualizing secondary successions. In the summer of 1988, wind-driven flames like those shown in the background swept through Yellowstone National Park, scorching nearly 1 million acres. The Yellowstone fire was one of the worst forest fires in United States history. The process of ecological regeneration triggered by fire. After the fire, burned timbers and blackened soil seemed to be all that remained. However, the fire didn't destroy the seeds that were protected under the soil. Many burned areas in the park opened new plots for stand-off trees. Within weeks, grasses and other plants were beginning to grow in the burned areas. Ecological succession underway. Climax community. A community has reached a stable stage of ecological succession is then called a climax community. It is a combination of plants and animals that use the available resources most efficiently. The beech maple forest shown is an example of a community that has reached the end of succession. Diversity and balance are maintained in a climax community because as trees die, they provide nutrients for new communities of organisms. Some physical disturbances also are important in maintaining equilibrium in a climax community. Primary successions begin in areas with no life at all. It can take hundreds or even thousands of years to develop into a climax community. Secondary successions is usually a shorter process, but it still can take a century or more. Biomass. Factors that affect biomes. Does a desert in Arizona have anything common with a desert in Africa? Both have heat, little rain, poor soil, water-conserving plants with thorns, and lizards. Even widely separated regions of the world can have similar biomes because They have similar climates. Climate is the average weather pattern in an area over a period of time. The two most important climate factors that affect life in an area are temperature and precipitation. Major biome. Large geographic area that have similar climates and ecosystem are called biomes. Seven common types of biomes are mapped, with similar climates produce several similar climate communities. Tropical rainforests are climate communities found near the equator. Temperature are warm and rainfall is plentiful. Coniferous forest grows where the winter temperature are cold and rain is moderate. 7 types of biomes are Africa, Australia, Asia, Europe, South Africa, North America, and North America. Tundra. At latitudes just south of the North Pole lies a biome that receive little precipitation but is covered with ice most of the year. The tundra is a cold, dry, treeless region. Sometimes called a cold desert. Precipitation average less than 25 centimeters per year. Winters can be 6 to 9 months long. For some of these months, when the sun never appears over the horizon, the land is dark 24 hours a day. The average temperature of the tundra is about 12 degrees Celsius. For a few days, during the short, cold summer, the sun is always visible. Only the top portion of soil thaws in the summer. Below the thawed surface is a layer permanently frozen soil called permafrost. Tundra soil has few nutrients because the cold weather or temperature slows the process of decomposition. Tundra life. Tundra plants are adapted to drought and cold. They include mosses, grasses, and small shrubs. As seen in the picture, many lichen grows in the tundra. Many lichen grows in the tundra. Tundra during the summer, mosquitoes, black fires, and other biting insects feed the air. Migratory birds such as ducks, geese, shorebirds, and songbirds nest in the tundra during summer. Other inhabitants include hawks, snowing owls, and willow grouse, mice, voles, lemmings, Arctic-hare, caribou, reindeer, and musk oxen also are found there. People are concerned about overgrazing by animals on the tundra. Fences, roads, and pipelines have disrupted the migratory routes of the animals and forced them to stay in a limited area because the growing season is so short. Plants and other vegetation can take decades to recover from damages. Permafrost in Alaska is covered by soils that freezes in the winter and thaws in the summer. Tiger. South of the tundra, between latitude 50° north and 60° north, and stretching across Canada, northern Europe, and Asia, is the world's largest biome, the taiga. Taigo is a cold forest region dominated by cone-bearing evergreen trees. Although the winter is long and cold, the taiga is warmer and wetter than the tundra. Precipitation is mostly snow and average 35 centimeters to 100 centimeters each year. Most soils of the taiga thaws completely during the summer. making it possible for trees to grow. However, permafrost is present. Is present in the extreme northern region of the Tiger. The forest of the Tiger might be so dense that little sunlight penetrates the trees to reach the forest floor. However, some lynching and mosses do grow on the forest floor. Moors, lions, shrews, bears, and foxes are some of the animals that live on the Tiger. Temperate deciduous forests. Temperate regions usually have 4 distinct seasons each year. Annual precipitation ranges from about 75 centimeters to 150 centimeters and is distributed throughout the year. Temperature ranges from below freezing during the winter to 30 degrees or more during the warmest of summer. Temperate forest life. Many evergreen trees shows grows in the temperate region. However, most of the temperate forests in Europe and North America are dominated by climbers communities. Of deciduous trees, which loses their leaves every autumn. These forests are called temperate deciduous forests. In the United States, most of them are located east of the Mississippi River. When European settlers first came to America, they cut trees to create farmlands and to supply wood. As forests were cut, organisms lost their habitats. When agriculture shifted from the eastern to the midwestern and western states, secondary succession began, and trees eventually returned to some area. Now, nearly as many trees grow in the New England states as did before the American Revolutionary War. Many trees are located in smaller patches, yet the recovery of large forests, such as those in the Adirondack Mountain in New York, shows that succession is possible. human impact. Farmers that live in tropical areas clears the land to farm and sell valuable wood. After a few years, the crop uses up nutrients in the soil, and the farmers must clear more land. As a result, tropical forest habitats are being destroyed. Through education, people are realizing the value and potential value of preserving the species of the rainforest. In some areas, logging is prohibited. In other areas, farmers are taught new methods of farming, so they do not have to clear rainforests continually. Emergence. These giant trees are much higher than the average canopy tree. Birds, such as the macaw and the insects, are found here. Canopy. The canopies include the upper part of the tree. It is full of life. Insects, birds, reptiles, and mammals. Understory. This dark, cool environment is under the canopy leaves, but above the ground. Many insects, reptiles, and amphibians live in the understory. Forest floor. The forest floor is full of life. Many insects and the largest mammals in the rainforest generally live here. Deserts. When vegetation is removed from the soil in areas that receive little rain, the dry, unprotected surface can be blown away. If the soil remains bare, a desert might form. This process is called desertification. Look on a biomed map and hypothesize about which area of the United States are most likely to become deserts. The driest biome on Earth is the desert. Deserts receive less than 25 centimeters of rain each year. And support little plant life. Some desert areas receive no rain for years. When rain does come, it quickly drains away. Any water that remains on the ground evaporates rapidly. Most deserts, like the one in Figure 13, are covered with a thin, sandy, or gravelly soil that contains little organic matter due to the lack of water. Desert plants are spaced far apart, and much of the ground is bare. Barren, wind-blown sand dunes are characteristics of the driest deserts. Desert life. Desert plants are adapted for survival. In the extreme dryness and hot and cold temperature of this biome, Cactus plants are probably the most familiar desert plants of the Western Hemisphere. Desert animals also have adaptations that help them survive the extreme conditions. Some, like the kangaroo rat, never needs to drink water. They get all the moisture they need from the breakdown of food during ingestion. Most animals are active only during the night, late afternoon, or early morning, when temperatures are less extreme. Few large animals are found in the desert. In order to provide water for desert cities, rivers and streams have been diverted. When this happens, wildlife tend to move closer to cities in search for food and water. Education about desert environment has led to an awareness of the impact of human activities. As a result, large areas of deserts have been set aside as national parks and wilderness areas to protect desert habitats. Grassland. Temperate and tropical region that receives 25 centimeter and 75 centimeter of precipitation each year are dominated by climbers communities of grasses. They are called grassland. Most grassland have a dry season. When little or no rainfall, this lack of moisture prevents the development of forests. Grassland are found in many places around the world, and they have variety of names. Grassland have animals that usually gaze on stem, leaves, seeds of grass plants. Lack of moisture prevents development of forests. The prairies and plains of North America, the steppes of Asia, the savanna of Africa, and the pampas of South America are type of grassland. Grassland lives. The most noticeable animals in grassland biome are usually mammals. That gaze on stem, leaves, and seed of grass plants. Kangaroos graze in the grassland of Australia. In Africa, communities of animals such as wild beasts, impalas, and zebras thrives on savanna. Thrives in the savanna. Grasslands are perfect for growing many crops such as wheat, rice, oats. Barley and corn. Grasslands also are used to raise cattle and sheep. However, overgrazing can result in the death of grasses. And the loss of valuable topsoil from erosion. Most farmers and ranchers take precautions to prevent the loss of valuable habitats and soil. Animals such as zebras and wild beasts feed on the grasses of the savanna in Africa. Studying a land ecosystem, aquatic ecosystem. Freshwater ecosystem. In a land environment, temperature and precipitation are the most important factors that determine which species can survive. In aquatic environments, water, temperature, the amount of sunlight present, and the amount of dissolved oxygen and salt in the water are important. Earth's freshwater ecosystem include flowing waters such as rivers and streams, and standing water such as lake, pond, and wetlands. Rivers and streams. Flowing freshwater environment varies from small, gurgling brooks to large slow motion river. Currents can quickly wash loose particles downstream. Leaving a rocky or a gravelly bottom. As the water tumbles and splashes, air from the atmosphere mixes in. Naturally, fast flowing streams usually have clearer water and higher oxygen content than slow flowing stream. Most nutrients that support life in flowing water ecosystem are washed into the water from land. In areas where the water movement slows, such as in the pool of streams or in a large river, debris settles to the bottom. These environments tend to have higher nutrient level and more plant growth. They contain organisms that are well adapted to swiftly flowing water, such as freshwater mussels, minnows, and leeches. Streams like this one are high in oxygen because of the swift tumbling water, where the most nutrients in the stream come from. Human impact. People use rivers and streams for many activities. Once regarded as a free place to dump sewage and other pollutants, many people now recognize the damage this causes. Treating sewage and restricting pollutants have led to an improvement in the water quality. But lake and ponds. When a low place in the land fills with rainwater, snow melts, or water from an overflowing stream, a lake, pond, or pond mite forms. Pond or lake water hardly moves. It contains more plant growth than flowing water environments contain. Lakes, such as the one we've seen, are larger and deeper than pond. They have more open water because most plant growth is limited to shallow areas along the shoreline. In fact, organisms found in the warm sunlight water of the shorelines often are similar to those found in the ponds. If you were to dive to the bottom, you would discover few. If any plants or algal growth, colder temperature and lower light level colder temperature and lower light level limits the types of organisms that can live in deep lake waters. Floating in the warm sunlight waters near the surface of freshwater lakes and ponds are microscopic algae, plants, and other organisms known as plankton. A pond shown in figure 16b is a small, shallow body of water. Because ponds are shallow, they are filled with animals and plant life. Sunlight usually penetrates to the bottom. The warm sunlight water promotes the growth of plants and algae. In fact, many ponds are filled completely with plant materials. So, the only clear open water is at the center. Because of the lush growth in pond environments, they tend to be high in nutrients. The population of organisms in the shallow water is high. Fewer types of organisms can live in the deeper water. Ponds contain more vegetation than lake contain. Water pollution. Human activities. People use rivers and streams for many activities. Human activities can harm freshwater environments. Fertilizers feed runoff from farms and lawns, as well as sewage dumped into the water can lead to excessive growth of algae and plants in lakes and ponds. The growth and decay of these organisms reduce the oxygen level in the water, which makes it difficult for some organisms to survive. To prevent problems, sewage is treated before it is released. People also are being educated about problems associated with lakes and pond pollution. Fines and penalties are issued to people caught polluting waterways. This control have led to recovery of many freshwater ecosystems. Wetlands, as the name suggests, shown here are regions that are wet for all of most of the year. They are found in regions that lie between land masses and water. Other names for wetland include swamp bogs and fens. Some people refer to wetland as biological supermarkets. They are fertile ecosystem and plants, but only plants that are adapted to waterlogged soil could survive there. Wetland animals include beavers, migratory birds. Population use wetlands as breeding ground. Wetlands once were considered to be useful disease-ridden places. Many were drained and destroyed to make roads, farmlands, shopping centers, and housing development areas. Only recently have people begun to understand the importance of wetland. Well, products that comes from wetland, including fish, shellfish, cranberries, and plants, are valuable resources. Now, many developers are restoring wetlands in some states. In most states, access to land through wetlands are prohibited. Life in Florida Everglades was threatened due to pollution, drought, and draining of the water. Conservation efforts are being made in an attempt to preserve this ecosystem. Osmosis is the movement of water molecule through a membrane from an area where there are more of them compared to other molecules present to an area where there are fewer of them, higher concentration to lower concentration. The blood of a freshwater fish is saltier than the lake water. Explain in your science. Saltwater ecosystem. About 95% of water on the surface of the earth contain high concentration of various salts. The amount of the dissolved salt in water is called salinity. Saltwater ecosystems include ocean, sea, a few inland lakes, such as the Great Salt Lake in Utah, coastal inlets, and estuaries. Open ocean. Life abound in the open ocean. Scientists divide the ocean into different life zones based on the depth to which sunlight penetrates the water. The lighted zone of the ocean is upper 200 meters or so. It is the home of the planktons that make up foundation of the food chain. In the open ocean, below are solid method from the lighted zone, or animals living in this region feed on materials that float down from the lighter zone, or they feed on each other. A few organisms are able to produce their own food. Coral reefs. One of the most diverse ecosystems in the world is the coral reefs. Coral reefs are formed over a long period of time. From the calcium carbonate shells secreted by animals called corals to when coral die, their shell remain. Over time, the shell deposits from reefs such as the Great Barrier reefs off the coast of Australia. Shown in figure 18. Reefs do not adapt well to long-term stress. But runoffs from feed, sewage, and increased sedimentation from clear land harms reef ecosystem. Organizations like the Environmental Protection Agency have developed management plans to protect the diversity of coral reefs. This plan treats a coral reef as a system that includes all the areas that surround the reef. Keeping the areas around reef healthy will result in a healthy environment for the coral reef ecosystem. Now, these plans, organizations like the Environmental Protection Agency have developed management plans to protect the diversity of coral reefs. These plans treat a coral reef as a system that includes all the areas that surround the reef. Keeping the area around reef healthy will result in a healthy environment for the coral reef ecosystem. The lighter area around this island are part of the Great Barrier Reef. Reef contains colorful fish and a large variety of other organisms. Seashores. All of Earth's mass are bordered by shorelines. All of Earth's landmass are bordered by ocean water. The shallow water along the world coastline contain a variety of saltwater ecosystems, all of which are influenced by the tides and by the actions of waves. The gravitational pull of the sun and moon on Earth causes the tide to rise and fall each day. And all these, which include a variety of saltwater ecosystems, and these are all influenced by the tide and action of the wave. The height of the tide varies according to the phases of the moon, the season, and the slope of the shoreline. The intertidal zone is a portion of the shoreline that is covered with water at high tide and is exposed to air during low tide. Organisms that live in the intertidal zone, such as those, must be adapted to dramatic changes in temperature, moisture, and salinity, and must be able to withstand the force of wave action. Estuaries. Almost every river on Earth eventually flows into an ocean. The area where a river meets an ocean and contains a mixture of fresh water and salt water is called an estuary. Estuaries, other names for estuaries include bay lagoon, bay, lagoons, harbors, inlets, and sound. They are located near coastline and border of the land. Salinity in estuaries changes with the amount of fresh water brought in. By rivers and streams, and with the amount of salt water pushed inland by ocean tide. Estuaries shown are extremely fertile. productive environment, and because freshwater streams bring in tons of nutrients washed from inland soil. Therefore, nutrient level in estuaries are higher than in freshwater ecosystem or other salt water ecosystem. Estuary life. Organisms found in estuaries include species such as algae, salt-tolerant grasses, shrimps, crabs, clams, oyster, snail, worms, and fish. Estuaries also serve as important nursery for many species of ocean fish. They provide much of the seafood consumed by humans. Fish and shrimps are harvested by commercial fishing boats. Exploring wetlands. Wetlands, such as the one shown below, are an important part of the environment. These fertile ecosystems support unique plants and animals that can survive only in wetland conditions. The more you understand the importance of wetlands, the more you can do to preserve and protect them. Recognize the problem. Why are wetlands an important part of the ecosystem? Form an hypothesis. Why do wetlands need to be protected? What are the laws in place to protect wetlands? Form an hypothesis about why wetlands should be protected. Your goals should be to identify wetland region in Nigeria or any part of Africa, describe the significance of the wetland ecosystem, identify plant and animal species native to a wetland region, identify strategies for supporting the preservation of wetland. We are changing the United States here to Nigeria. Plan. Test your hypothesis. Plan. You do, analyze your data, and you draw your conclusion. Helping nature help itself. Creating wetlands to purify wastewater. Pebbles were added to the corals wetland to help with drainage. Water irises thrive in the wetland less than a year after planting. Students enjoy pure water from the corals wetland after it is filtered. Now, when you wash your hand or flush the toilet, you probably don't think much about where the wastewater goes, or in most cases, in most places, it eventually ends up being processed in a traditional sewage treatment facility. But a handful of places are experimenting with new methods that processes wastewater by creating wetlands. Wetlands such as swamps or marsh are home to featuring plants such as catfish and sewage-eating bacteria. In 1996, school officials of the Korat elementary school in the city of Albuquerque, New Mexico, face a big problem. The old wastewater treatment. The old wastewater treatment system has failed. Replacing it is going to cost a lot of money. The school officials came up with a few things or ways of how we could replace it. They came up with an alternative plan. Instead of constructing a new sewage treatment plant, they decided to create instead a natural wetland system. The wetland system could do the job less expensively. While protecting the environment. The government inspector listened to my idea, saw the sense in it, today, this wetland efficiently converts polluted water into cleaner water that is good for the environment. US officials are closely watching this alternative sewage system. To see how successful it is. So far, so good. And if it continues to work well, Other communities may start creating wetlands to filter their sewage. How wetlands work. Wetland filters water through the action that the plants and microorganisms that live there perform. When the plants absorb water into air, when the plants absorb water into air, into their roots, some, such as cattails, are also take up pollutants. The plants they take up pollutants. The plant convert the pollutants to forms that are not dangerous. At the same time, bacteria and other organisms have plenty of time to do their work. They are being filtered. They are filtering water as they feed. Water does not move quickly through wetlands, so the organisms have plenty of time to do their work. The wetland built at Korea's elementary is called a constructed wetland. That is a wetland built by people to filter small amounts of pollutants. In many cases, constructed wetlands are better at cleaning wastewater than sewers or septic wetlands. From sewage to flower. Nancy Gregor is a wetland plant. Is a wetland plant expert. Planted a variety of colorful plants that bloom at different times of the year. Wetland and sewers. Wetland and sewers a local official said school classes are taking field trip to wetlands to learn what plants do as part of the environment. It becomes a real educational asset. Conserving resources. natural resources under resources. An earthworm burrowing in soil. An earthworm burrowing in more soil eats decaying plant materials. A robin catches the earthworm. A robin catches the earthworm and flies to a tree. The robin, the leaves of the tree uses sunlight during photosynthesis. So then, the robin leaves falls to the ground, decay. And perhaps become an earthworm meal. What do these living things have in common? They rely on Earth's natural resources. Renewable resources. The sun, an inexhaustible resources. Provide constant supply of heat and light. Rain fills lakes and streams. And streams with water. When plants carry out photosynthesis, they add oxygen to the air, sunlight, water. They add oxygen to the air, sunlight, water, air. And everything needed for that plant to grow well. But these resources are renewable resources. A renewable resources is any natural resources that is replaced, refilled, or recycled by nature. Supply and demand. Even though renewable resources are recycled, we still place importance on them because they are sometimes in short supply. Rain and melted snow replace the water in stream, lake, and a couple of other areas. And in some part of the world, especially desert region, waters and other resources usually are scarce. But then, it may not sometimes rain and melted snow replace the water in stream, lake, and reservoirs. Sometimes there may not be enough rain or melted snow to meet everyone's needs. It may actually not be enough. But what we do is to ensure that in some part of the world, especially the desert region, other resources like water and other things can be used instead. Non-renewable resources. Non-renewable resources include the following. They are natural resources that are used up more quickly than they can be replaced. And they are non-renewable resources. Earth supply non-renewable resources. And they are limited. Earth supply of non-renewable resources are limited. You use non-renewable resources when you take home groceries in a plastic bag, when you paint a wall, or travel by car. Plastic, paint, and gasoline are all parts of non-renewable resources. And they can be called petroleum or oil. Petroleum is formed mostly from the remains of microscopic marine organisms buried in the earth crust. It is non-renewable because it takes hundreds of years to form. Because it is non-renewable, we as a people want to make sure that it doesn't harm the earth. Minerals and metals found in the earth crust are non-renewable because petroleum is a mineral, so are diamonds and the graphites in pencil lead. The aluminium used to make soft drinks can is a metal. Iron, copper, tin, gold, silver, tungsten, and uranium are also metals. Many manufactured items, like the car shown, are made from non-renewable resources. In part of Africa, firewood has become scarce because villages, people in these villages now use solar energy instead of wood for cooking. Iron is a non-renewable iron is a non-renewable resources. Its main ingredient is tea. And steel is used to make car, trucks, appliances, bridges, and even fire. What other non-renewable resources can you name? Fossil fuel. Coal, oil, and natural gas are non-renewable. Earth's supply of them is limited. In the future, they may become more expensive and difficult to obtain. Also, the use of fossil fuel can lead to environmental problems. For example, Mining coal can require stripping away thick layers of soil and rocks, as shown in Figure 4, which destroys ecosystem. Another problem is that fossil fuel produces wet gases that causes air pollution, including smog and acid rain. For these reasons, many people suggest reducing the use of fossil fuel and finding other resources of energy. You can use simple conservation measures to help reduce fossil fuel for use. Switch off the lights when you leave a room and turn off the TV when you are not watching it. This action reduces your use of electricity, which often is produced in power plants that burns fossil fuel. Hundreds of millions of automobiles are in use in the United States and in all countries over. Riding in a car pool or taking public transportation use fewer liters of gasoline than driving alone in a car. Walking or riding a bicycle uses even less fossil fuel. Reducing fossil fuel use has an added benefit. The less you use, the more money you save. 5. Coal is a fossil fuel. It often is obtained by strip mining, which removes all the soil above the coal deposits. The soil is replaced, but it takes many years for the ecosystem to recover. The graph shows that 84% of the energy used in the United States came from fossil fuel. Alternatives to fossil fuel. Most power plants use turbine generator to produce electricity. In fossil fuel plants, burning fuel boils water and produces steam that turn the turbines. Fast-moving steam water or wind rushes across the turbine's blade. The flow of the energy causes the turbine blade to turn. The turbine blades are attached to a shaft. When the blade turns, so does the shaft. Electricity flows from the coil to the electrical wire. Turning shafts is connected to an electric generator. A simple generator is a coil of fire that spin inside the field of a magnet. The turbine shafts spin the coil, and spinning coil generates electricity. Alternatives to fossil fuels. Another approach to reducing fossil fuel use today is to develop other sources of energy. Much of the electricity used today comes from power plants that burn fossil fuels. As Figure 5 shows, electricity is generated when a rotating turbine turns a coil of fire. Also, solar cell can produce electricity particularly considered inexhaustible resources. Water power. Water is a renewable energy source that can be used to generate electricity. Hydroelectric power is electricity that is produced when the energy of falling water is used to turn the turbines of an electric generator. Hydroelectric power does not contribute to air pollution because there is no fuel burnt. Building a hydroelectric plant usually presents environmental concern because it involves a dam across a river. The dam raised the water level high enough to produce the energy required for electricity generation. Many acres behind the dam are flooded, destroying land, habitats, and changing parts of the river into a lake. Potential energy is stored energy. Kinetic energy is motion energy. Like a car moving along the streets in your science journal. Wind power. Wind power. Wind power is another renewable energy source that can be used for electricity production. Wind turns the blade of a turbine, which powers an electric which powers an electric generator. When wind blows at least 32 km per hour, energy is produced. Wind power does not cause air pollution, but but it is reduced for only a small percentage of the electricity used worldwide. So far, wind power accounts for only a small percentage of the electricity used worldwide. Nuclear power. Another alternative to fossil fuel make use of the huge amount of energy in nuclei of atom. Such atomic nuclei from uranium, a radioactive element, are split apart in a clear fission reaction. This energy is used to produce steam that rotates the turbine blade of an electric generator. Nuclear power does not contribute to air pollution. However, uranium a radioactive element, are split apart in a nuclear fusion reaction. This energy is used to produce steam that rotates the turbine blades of an electric generator. Nuclear power does not contribute to air pollution. Uranium is non-renewable. It's a non-renewable resource, and mining it can disrupt ecosystem. Nuclear power plants also produce radioactive waste. Nuclear power plants also produce radioactive waste. Some of these wastes remain radioactive for thousands of years, and their self-disposal is a problem that has not yet been solved. Accidents are also in danger. Accidents are also in danger. Accidents are also a danger. Nuclear power are designed to withstand the high energy produced by nuclear reactions. 1. The containment building is made up of concrete lined with steel. The reactor vessel and steam generators are housed inside. Steam generators, steel lining, cooling power pumps, containment building, control rods, reactor vessels, fuel rods, containment buildings. The containment building is made up of concrete lined with steel. The reactor vessels and steam generators are housed inside. The uranium fuel rod are lowered to begin the nuclear action. Rods made of radiation absorbing materials can be raised and lowered to control the reaction. A fast-moving neuron from the nucleus of a uranium atom crashes into another atom. The collision splits the atom, releasing more neutrons, which collide with other atoms or are absorbed by control rods. The heat produced by this collision is used to produce steam, geothermal energy. The Earth's molten rocks that lies deep beneath Earth's surface is also a source of energy. You see the effects of this energy when lava and hot gases escapes from an erupting volcano, or when hot water spills from a geyser. The heat energy contained in Earth's crust is called geothermal energy. Most geothermal power plants use this energy to produce steam or generate electricity. Geothermal energy for power plants is available only where natural geysers or volcanoes are found. Most geothermal powers using this energy due to steam to generate electricity. Outdoor swimming areas are heated with geothermal energy. as shown in Fig 7. Solar energy. The most inexhaustible source of energy for all life on earth. For all life on earth, what is that? Is the sun. Solar energy is an alternative to fossil fuel. One use of solar energy is in solar heated building. During winter, in the northern hemisphere, the parts of a building that face south receive the most sunlight. Large windows placed on the south side of a building help heat it by allowing warm sunshine into the building during the day. Floors and walls of most solar buildings are made of materials that absorb heat during the day. Keeping the building warm. Shows how solar energy can be. In Ireland, a geothermal power plant pumps hot water out of the ground to heat buildings and generate electricity. Leftovers hot waters goes into this lake. Making it warm enough for swimming, even when the ground is covered with snow. The Zion National Park Visitor Center in Utah is a solar heated building designed to save energy. That energy from sun travel in tiny packet of energy called photons. Photons crashes into the atom of PV cells, knocking electrons loose. These electrons create an electrical current. So that's do you know how a solar cell powered calculator works. How do spacecraft use sunlight to generate electricity? As shown, photovoltaic cells are small and easy to use. However, they produce electricity only in sunlight. So, batteries are needed to store electricity for use at night on a cloudy day. Shows solar building and PV cells are just two of the many ways solar energy can be used to replace fossil fuel. Visualizing solar energy. Sunlight is a renewable energy source that provides an alternative to fossil fuel. Solar technologies uses the sun energy in many ways. From heating to electricity generation. Electricity. Photovoltaic cells from sunlight into electric current are commonly used to power small devices such as calculators, panels that combine many PV cells, provide enough electricity for home, so electricity on orbiting satellites such as the International Space below. Cooking. in hot cooking in hot sunny weather. Can be used rice cooker. The powerful solar cooker shown below turns the room into a solar collector. Water heating. Power plant in California moved desert, an experimental solar place. In hot sunny weather, a solar oven or photovoltaic PV cells turns serious. They are commonly used to power small devices. They are commonly used to power small devices, such as frying of food, honey cooker, a powerful solar cooker, higher temperature. It is being used to fry food. Indoor heating. South facing windows and heat absorbing construction material can turn into a solar collector. An entire building such as this could be powered fully by solar. Buildings like that already exist. Electricity cells turn sunlight into electric current. Panels are panels such as calculators are combined many panels here provide enough electricity for a home or an orbiting satellite. Such as international space stations, you water heating. Water is heated as it flows through small pipes. Pollution. Keeping the environment healthy. More than 6 billion people on Earth. This large human population put a stain on the environment. But each person can make a difference. We can help safeguard the environment by paying attention to how you use your natural resources. Affect air, land, and water. On a still sunny day in almost any city, you can still see a haze in the air. Whatever cars, trucks, airplane, or logistics we are doing is covered by me. Now, smoke is a form of air pollution. Created when the producers wanted me to talk, but now each person can make a difference. We all need to put our heads together to make that difference. Air pollution. keeping the environment healthy. This large human population put a stain on the environment. The environment is no longer healthy. Each of you can make a difference. Can help safeguard the environment. By paying attention to how you use your natural resources and how it affects air, land, and water. On a still sunny day, in almost any large city, you may see a dark haze in the air, like that in figure 11. Air pollutants include soot, smoke, ash, and gas, carbon dioxide, carbon monoxide, nitrogen oxide, sulfur oxide, whatever car oxide that is a pollutant. However, air pollution can also be caused by volcanic eruption, wind blow dust, and sand forest fire, and the evaporation of paints and other chemicals. Smog is one form of air pollution created when sunlight reacts with pollutants produced by burning fuel. It can irritate the eyes and make breathing difficult for people with asthma or other lung disease. Smoke can be reduced if people take buses or trains instead of driving, or if they use things as electric cars just to keep everywhere clean. Such as electric car that produce fewer pollutants than gasoline vehicles. Acid precipitation, chemical integration. Water vapor condenses on dust particles in the air to form droplets that combines to create cloud. Eventually, the droplet becomes large, combines, and you can combine it to whatever is being shown. Acid precipitation washes nutrients from the soil, which can lead to the death of trees and other things. Now, acidity is measured by a value called pH. Eventually, as shown, acid precipitation has a pH below 5.6. Effects of acid rain. Acid precipitation washes nutrients from the soil, which can lead to the death of trees and other plants. Runoff from acid rain that flows into lake or pond can lower the pH of water. If algae and microscopic organisms that depend on them for food also die, and it has ended, preventing acid rain. Sulfur from food. Sulfur from burning coal and nitrogen oxygen oxide from vehicle exhaust are the pollutants primarily responsible for acid rain. Also, using low sulfur fuel such as natural are more expensive than high sulfur coal. Smokestack that remove sulfur dioxide before it enters the air also helps. However, these foils are funny when seen. Acid rain are more expensive than high sulfur coal. Smokestacks that remove sulfur dioxide before it enters the atmosphere helps. The use of acid rain. The use of acid rain. Greenhouse effect. Sunlight travels through the atmosphere to Earth's surface. Some of this sunlight normally is reflected back into space. The rest is trapped by certain atmospheric gas. This heat trapping feature of the atmospheric greenhouse effect, temperature on Earth probably would be too cold to support life. The atmosphere might be trapping more of the sun heat, making Earth warmer. A rise in Earth's average temperature, possibly caused by an increase in greenhouse gas, is known as global warming. Global warming. Temperature data collected from 1895 through to 1995 indicates that Earth's average temperature increased about 1 degree Celsius. During 100-year period, no one is certain whether this is caused by human activity or a natural part of natural parts of Earth's weather cycle. What kind of changes might be caused by global warming? Changing rainfall patterns. Changing rainfall patterns could alter ecosystems and affect the kind of crops that can be grown in different parts of the world. The number of storms and hurricanes might increase. The polar ice caps begin to melt. Warmer weather might allow the polar ice cap to melt. And warmer weather might also allow tropical disease such as malaria, to become more widespread. Many people feel that the possibility of a global warming is a good reason to reduce fossil fuel use. Ozone depletion. About 20 kilometers above Earth surface is a portion of the atmosphere known as the ozone layer. Ozone is a form of oxygen. They absorb some of the sun harmful ultraviolet radiation. Ozone can damage living cells. Every year, the ozone layer temporarily becomes thinner. For over each polar region during the spring season. The thinning of the ozone layer is called ozone depletion. This is a problem, especially caused by pollutant gas. Ultraviolet radiation. Because of ozone depletion, by certain pollutant gases, especially chlorofluorocarbon, CFC, are used in cooling system of refrigerators, freezers, and air conditioners. When CFCs leaks into the air, they slowly rise into the atmosphere. Because of ozone depletion, when CFC leaks into the air, they slowly rise into the atmosphere until they arrive at the ozone layer. CFCs react chemically with ozone, breaking apart the ozone molecules. Ultraviolet radiation. Because of ozone depletion, the amount of UV radiation that the amount of UV radiation that reaches Earth's surface could be increasing. UV radiation could be causing a rise in the number of skin in the number of skin that can cancel cases in human. It also might be harming other organisms. The ozone layer is so important to the survival of life on Earth that the world government and industries have agreed to stop making and using CFR. Ozone that is high. Ozone that is high in the atmosphere, in the upper atmosphere, protect lives on Earth. Lives on Earth. Ozone stays in the lower atmosphere where it pollutes the air. Ozone damages the lungs and other sensitive tissues of animals and plants. For example, it can cause the needles of a ponderosa pin to drop, harming growth. What is the difference between ozone atmosphere and ozone pine to drop, harming growth? The atmosphere ozone layer absorbs large amount of UV radiation, preventing it from reaching Earth's surface. Ozone molecules are made of three oxygen atoms. They are formed in a chemical reaction because the oxygen you breathe has two oxygen atoms, in which no molecule atom in each molecule. Indoor pollution. Carbon monoxide enters the body through the lungs. It is attached to red blood cell, preventing the cell from absorbing oxygen in your science journal. Explain why heaters and barbecues designed for outdoor use, never to be used indoor. Air pollution. Air pollution can occur indoors. Today buildings today buildings are better insulated to conserve energy. However, better insulation reduces the flow of air into the heart of a building. Better insulation of flow reduce the flow of air into and out of a building, so air pollution or air pollutants can build up indoors. For example, burning cigarettes release hazardous particles and gases into the air. Even non-smokers can suffer even non-smokers can suffer ill effects from secondhand cigarette smokes. As a result, smoking is no longer allowed in many public and private bookings. Paints, carpets, glue, and adhesive, printers, and photocopying machines also gave up dangerous gases, including formaldehyde, like cigarette smoke. Formaldehyde, formaldehyde like cigarette smoke is a carcinogen, which means it can cause cancer. Carbon monoxide, carbon is a poisonous gas that is produced whenever charcoal, natural gas, kerosene, or other fuels are burned. CO poisoning can cause serious illness or death. Fuel burning stoves and heaters must be designed to prevent CO from building up indoors. CO is colorless and odorless, so it is difficult to detect. Carbon monoxide is being used in more and more homes. Radon. Radon is a naturally occurring radioactive gas. And is released radioactive gas that is given off by some type of rock and soil, as shown in figure 15. Radon has no color or odor. It can seep into basements and the lower floors of buildings. Radon exposure is the second leading cause of lung cancer in this country. A radon detector sounds an alarm when levels of gas in indoor air becomes too high. If random is present, increasing a building ventilation can eliminate any damaging effects. A random detector sound an alarm. A random detector increasing a building ventilation can eliminate any damaging effects. A. When rains fall on the road and parking lot, it can wash grease and oil onto the soil and into nearby streams. Rain can wash agricultural pesticide and fertilizers into lake or ocean stream. Industrial waste are sometimes released directly into surface waters. Water pollution. Pollutants enter water too. Air pollutants can drift into water or be washed out of the sky by rain. Rain can wash land pollution into waterways. As shown, water pollution wastewater from factories and sewer treatment plants is released into waterway. Laws requires that wastewater be treated to remove pollution. But in many parts of the world, wastewater treatment is not always possible. Pollution also enters water when people dump litter or waste material into river, lake, and ocean. Surface water. Some water pollutants, such as surface water, that is, wastewater from factories, sewage, treatments, is not always possible. Pollution also enters water when people dump litters or waste materials into lakes and ocean. Surface water. Surface water. Some water pollutants, poison, fish, and other wildlife can be harmful to people who swim in or drink water. Who swim in or drink water before it is released. But in many parts of the world, pollutants also enter. Pollution water also, before it is released, wastewater can be treated to remove pollutants. Pollution water some pollutants some water pollutants wastewater treatment is not always possible. Pollution also enter water when people dump litter or waste material into water. Some water pollution poison fish and other wildlife and can be harmful to people who swim in or drink the water. For example, chemical pesticide sprays birds and other animals, algae bloom, or other pollution problem. They are decomposed by their large numbers of bacteria that can be used in the water. Fish and other organisms can die for the lack of oxygen in water. In 1996, the oil tanker Sea Express spilled more than 72 million kg of oil into the sea. $40 million was spent on cleanup efforts, but thousands of ocean organisms were destroyed, including birds, fish, and shellfish. Rivers and streams eventually flowed into ocean, bringing their pollutants along. Also, polluted water can enter the ocean in coastal area where factory, sewage treatment, plant, or shipping are. Oil spills. Also, polluted water can enter the ocean in coastal area where sewage treatment or shipping activities are located. Oil spill are well known ocean pollution problem. About 40 billion kg of oil are spilled into ocean every year. Soil loss. Soil loss. Fertile topsoil is important to plant fertile topsoil is important to plant growth. New topsoil take hundreds of thousands of years to form. The explore activities at the beginning of this chapter shows that rain washes away loose topsoil and wind also. Wind also blows away. Soil pollution can become soil pollution can become topsoil. Wind also blows it away. The movement of soil from one place to another is called erosion. Eroded soil that washes into a river or stream can block sunlight and slow photosynthesis. It can also harm fish, clams, and other organisms. Erosion is a natural process, but human activities increases it. When a farmer plows a field or a forest is cut down, soil is left bare. Bare soil is more easily carried away by rain and wind. Soil pollution. Solid waste. What happens to the trash you throw out every week? What happens to the trash you throw out every week? What do people do with old refrigerators, TVs, or toys? Most of this solid waste is dumped in landfills. Most landfills are designed to seal out air and water. This helps prevent pollutants from seeping into surrounding soil. But it is slow, normal decay processes. Even food scrap cannot be accosted for. Even food stamps and paper cannot be accosted for. Usually, breakdown can last for decades in landfills area. It fills up quickly, and reducing the amount of trash people generate can reduce the need for a landfills. Hazardous waste. Waste materials that are harmful to human health or poisonous to living organisms are hazardous. They include dangerous chemicals such as pesticides, oil, petroleum-based solvents used in industry. They also include radioactive materials to treat diseases and form nuclear weapon production. Many household items are also considered hazardous. Hazardous wastes usually are handled separately from other type of trash. They are sealed in drums or treated in some ways to prevent them from polluting the environment. You can create models of health with and without heat reflecting greenhouse gases. Then, experiment with models to observe the greenhouse effect. What you investigate. How does the greenhouse effect influence temperature on Earth? Go. Observe the greenhouse effect. Describe the effect that a heat source has on an environment. Material. The 3 arrows of conservation. Conservation. A teacher travels to school in a carpool. In the school cafeteria, students place glass bottles and cans in separate containers from the rest of the bottles. Conservation efforts like these can help prevent shortages of natural resources, slow growth of landfills, reduce pollution level, and save people's money. Every time a new landfill is created, an ecosystem is disturbed. Reducing the need for landfill is a major benefit of conservation. The 3 arrows of conservation are reduce, reuse, and recycle. You contribute to conservation whenever you reduce your use of natural resources. You use less fossil fuel when you walk or ride the bicycle instead of taking the bus or riding in a car. If you buy a carton of milk, reduce your use of petroleum by telling the clerk you don't need a plastic bag to carry it in. You also can avoid filling the earth with materials that are not biodegradable. Packaging, or you can reduce your use of natural resources. Reuse. Another way to help conserve natural resources is to use items more than once. Reusing an item means using it again without changing or reprocessing it. Take reusable plates and utensils on picnics instead of disposables, paper, and items. If you can't avoid using an item and you can reuse it, the best thing is to recycle it. For the people in Edo State that have been saying they don't know how to recycle, there are companies who are actually into the recycling of these things. Recycling is a form of reuse that requires changing or reprocessing an item or natural resources. Plastic are more difficult to recycle than other materials, mainly because several types of plastic are in use. A recycle code marks on every plastic container indicates the type of plastic it is made of. Plastic soft bottles, like the ones shown, are made up of one plastic and are easiest to recycle. Most plastic bags are made up of two or four type of recycles. Plastics. Plastics can be reused. Plastic can be reused as well as recycled through various means. The type of plastic determines if it will be reused or recycled. What kind of plastics can be recycled? To find out more about recycling, see the recyclable plastic feed guide at the back of the door. I'll be taking some few minutes rest. Thank you very much. The three arrows of conservation. Students place glass bottles and cans in a separate containers from the rest of the garbage. Conservation efforts like this can help prevent shortage of natural resources. Slow growth. Of landfills, reduce pollution levels, and save people money. Every time a new landfill is created, an ecosystem is disturbed. Reducing the need for landfills is a major benefit of conservation. The 3 R's of conservation are reduce, reuse, and recycle. Reduce. You contribute to conservation whenever you reduce your use of natural resources. You use less fossil and when you walk or ride a bicycle, instead of taking a bus or driving in a car. If you buy a carton of milk, reduce your use of petroleum by telling the clerk you don't need a plastic bag to carry it in. You also can avoid buying things you don't need. For example, most of the paper, plastics, and cardboard used to package items for display on store shelves is thrown away as soon as the product is brought home. You can look for products with less packaging or with packaging made from recycled materials. What are some other ways you can reduce your use of natural resources? Reuse. Another way to help conserve natural resources is to use items more than once. Reusing an item means using it again without changing it or reprocessing it, as shown in figure 21. Bring your reusable canvas bag to the grocery stores to carry home your purchases. Donate clothes you have outgrown to charity so that others can reuse them. Take reusable plates and utensils on picnic instead of disposable paper items. Recycle. If you can't avoid using an item and you can't reuse it, the next best thing is to recycle it. Recycling is a form of reuse that requires changing or reprocessing an item or natural resources. If your city or town has a curbside or recycling program, You already separate recyclables from the rest of your garbage. Materials that can be recycled include glass, metals, papers, plastics, and yard and kitchen waste. Plastics. Plastic is more difficult to recycle than other materials, mainly because several types of plastics are in use. A recycle code mark on every plastic container indicates the type of plastic it is made of. Plastic soft drink bottle, like the one shown, are made of type 1 plastics that are easiest to recycle. Most plastic bags are made of type 2 or type 4 plastics. They can be reused as well as recycled. Type 6 and 7 can't be recycled at all because they are made of a mixture of different plastics. Each type of plastic must be separated carefully before it is recycled because a single piece of a different type of plastic can ruin an entire batch. What type of plastic can be recycled? To find out more about recycling, see the recyclable plastic feed guide at the back of the book. Many soft drink bottles are made of PET, PETE, which is the most common type of recyclable plastic. It can be melted down and spun into fibers to make carpets, paintbrush, ropes, and clothing. Methods. Automobile tires are almost indestructible. They usually are disposed of, but can have other useful purposes. What kind of plastic can be recycled? Methods. The manufacturing company or industry has been recycling all kinds of metals, especially steel, for decades. At least 25% of steel in cans, appliances, and automobiles are recycled steel. Up to 100% of the steel in plates and beams used to build skyscrapers is made from reprocessed steel. About 1 metric ton of recycled steel saved about 1.1 metric ton of iron ore and 0.5 metric ton of coal. Using recycled steel to make new steel products reduces energy use by 75%. Other methods, including iron, copper, aluminium, and lead, can also be recycled. Also, remember that recycled cans do not take up space in landfill. You can conserve method by recycling food cans, which are mostly steel and aluminum cans. It takes less energy to make a can from recycled aluminum than from a raw material. Also, remember that recycle can do not take up space in landfills. Glass. Glass bottles and jars can be sterilized and reused. They also can be melted and reformed into new bottles, especially those made of clear glass. Most glass bottles already contain at least 25% recycled glass. Glass can be recycled again and again and again. It never needs to be thrown away. Recycling about 1 metric ton of glass saves more than 1 metric ton of mineral resources and cuts the energy used to make new glass by 25% or more. Problem-solving activities. What items are you recycling at home? Many people participate in community recycling programs. Recyclable items such as plastic, glass, newspapers, and metals may be picked up at the curbside, or the resident may hire a licensed recycling handler to pick them up. What do you recycle at home? Paper. Used paper is recycled into paper toys, insulation, newsprint, cardboard, and stationeries. Ranchers and dairy farmers sometimes use shredded paper instead of straw for beddings in barns and stables. Used paper can be made into compost. Recycling about 1 metric ton of paper saves 17 trees, more than 26,000 liters of water, close to 1,900 liters of oil, and more than 4,000 kilowatts of electric energy. You can do your part by recycling newspapers, your notebooks, and printed papers, cardboard, and junk mail. Composting is a way of turning plant materials you would otherwise throw away into rich garden soil. Dry leaves and weed, grass clippings, vegetable trimmings, and non-eat food scrap can be composted. Compost. Glass clippings, leaves, and fruits, and vegetable scrap that are discarded in landfills can remain there for decades without breaking down. The same item can be turned into soil-reaching compost in just a few weeks. Many communities distribute compost bins to encourage residents to recycle fruits and vegetable scraps and yard wastes. Buy recycled. People have become so good at recycling that recyclable materials are piling up, just waiting to be put to use. You can help by reading labels when you shop and choosing products that contain recyclable or recycled materials. What other ways of recycling natural resources can you think of? What is meant by the term reuse? Solar cooking. The disappearance of forests in some places on Earth has made firewood extremely difficult and expensive to obtain. People living in this region often have to go or travel long distance to sell some of their food to get firewood. This can be a serious problem for people who may not have food to begin with. Is there a way they can cook food? Can you design a solar cooker that cooks food without burning foil? Practically, how would you build a cooking device? Strings, wire coat hangers, clear plastic sheets, oven bags, black cookware, thermometer, stopwatch timer, glue, tape, scissors, alternate material. Be careful when cutting your material. Your solar cooker will get hot when handling hot liquid or objects. Use insulated gloves or tongs. Go. Design for solar panel cooker or box cooker. Design a solar cooker that can be used to cook food. Plan an experiment to measure the effectiveness of your solar cooker. Check the model plan. Analyzing and applying results. Test it. Combine. Get approval. A nice model. Filthy plagiarized. I wandered home, lonely as a cloud, except from a motorboat. Now is so inside. Beside the lake, next to the barbed wire fence, there was a picnic table and a bottle cap for many years. A boat ramp to the left and a chimney from a power station on the other side. A summer haze hung in the air, and the laser drone of traffic far away. Crimson autumn of mist and mellows. Fruitfulness, blue plastic cover, a swimming pool, and then it snows. White lining on trees and rooftop, and through my windshield vipers, the snow is spiked dark and gray. Next to my driver, where I check my mail, a little footprint on fresh snow. I knew a bank where the white theme blows over canopied with luscious woodbine. It is now a landfill. Fermentation of civilization. Flowers on TV. Hyacinth rose. Tulip chrysanthemum. Acres of color. Wind up wrapped in decorous plastic. In this landfill where oslip grew, understanding literature, cause and effects, recognizing cause and effects. Relationship can help you make sense out of what you read. One event causes another event. The second event is the effect of the first event. In the poem, the author describes the causes and effects of pollution and waste. For example, the summer haze is the effect of the chimney from a power station, as well as the traffic far away. What other effect do pollution and the use of non-renewable materials can cause? Describing these four effects. Describing these four effects. Describing four seasons instead of one reinforced the poet message. Reinforce the poet message. The poet described renewable and non-renewable resources. For example, the lakes and trees described in the first verse are renewable resources. The beer bottle cap in the same verse are non-renewable. Can you identify all the non-renewable, and can you identify the renewable? The renewable resources in the poem. How does the narrator contribute to the use of fossil fuel and non-renewable resources? Write a poem. Copy the poem. You just write a poem. Copy the poem. You just read in pencil. Change the poem by erasing the lines that describes non-renewable resources. Add lines to the poem that shows how recycling, reusing, and reducing can have effects in what you do. Other conservation measures. Understanding literature. Causes and effects. Recognizing causes and effect relationship can help you make sense out of what you read. One event causes another event. The second event is the effect of the first event. Then in the poem, for example, the summer haze is the effect of the chimney from a power station, as well as the traffic far away. What other effects do pollution and the use of non-renewable resources have? The poets also make a connection between the 4 seasons of the year and the pollution and waste products. For example, in the spring, landfills for dumping garbage replace a field of wild flowers. And the beauty of nature has stolen or plagiarized science connection. The poet describes renewable and non-renewable resources. For example, the lake and tree. Describes in the first verse are renewable resources. The bare bottle cap. In the same verses are non-renewable. Can you identify the renewable resources in the poem? How does the narrator contribute to the use of the fossil fuel and non-renewable resources? Career, connection, ecologist. Vandana Shiva is the director of the Research Foundation for Science, Technology, and Natural Resource Policy in Dehradun, India. Shiva had an early appreciation for global natural resources. As a daughter of a forester, growing up in the Himalayan forest, her involvement in this movement led to the banning of loggings in the Himalayan area above 1,000 meters. Above 1,000 meters. Science Online. To learn more, about career in ecology, visit the Gleco Science website at sciencegleco.com. Conserving life. Every year, since you can remember, ouch, your family has driven to this remote area to speak on camping. And the view reminds you that your modern life comes at a cost. Even in the few years that you have been coming here, the fresh air, the lack of animals, birds, you notice that there are few birds. And other animal species than there used to be. In this chapter, you notice that you learn about the biodiversity, endangered species, as well as others. You will see that that enjoyment of nature is only one of the many important reasons for conserving life. What do you think? Look at a picture with a classmate, discuss hints. Do human actions or activities present an ecosystem? What happens to organisms that are pushed in this era? Recognize environmental difference using strings or tapes, marks, lawn or sidewalk. Count and record the different species of plants, insects, birds, organisms. Repeat step 1, step 2, and in a partially wooded area or at the edge of a pond. What kind of human action could have affected the environment at such a simple area? The variety of life, biodiversity. Imagine walking through a forest ecosystem like the one shown here. Trees, shrubs, and small plants are everywhere. Notice, you hear and you see squirrels, birds, insects. You might notice a snake, mushroom, or even hundreds of species that lives in the forest. Now, imagine walking around the forest. Imagine walking through a wheat field. The forest has a higher biological diversity. More species than the wheat field does. The forest has higher biodiversity, higher biological diversity, or biodiversity. Biodiversity refers to the variety of life in an ecosystem. Measuring biodiversity. The common measure of biodiversity is of the species live in that area. A coral reef has greater biodiversity than the shallow water that surrounds it. Before deep sea exploration, it was thought that few organisms could live in dark, deep sea waters. Although it is estimated that the number of organisms living there is less than the number of organisms on a coral reef. It is known that the biodiversity of deep sea water is as great as that of coral reef. Biodiversity is broad and great. Figure 1. The forest has more species and is richer in biodiversity than a wheat field. Knowledge of biodiversity can lead to strategies for preventing loss of species. This map shows the number of mammals. In general, biodiversity increases as you get closer to the equators. Difference in biodiversity. Biodiversity tends to increase as you move towards the equator because temperature tends to be warmer. In the ongoing biodiversity, the species, many bird species as there are in the United States. Biodiversity tends to increase by warmer. For example, Costa Rica is a Central American country about the size of West Virginia. There, in the United States and Canada combined, compare mammal biodiversity in 3 North American countries. Ecosystem with the highest biodiversity usually have warm, moist climates. In fact, tropical region contains 2/3 of all land species. Why is that biodiversity important? Would you rather have a summer picnic or a paved parking lot? Many people like to find pleasure in things and nature biodiversity. Perhaps you like to visit scenic area to hike, swim, relax, or enjoy. However, beauty and pleasure are not the only reasons why biodiversity is important. However, human needs biodiversity. What food do you like to eat? If you eat meat or rice or fish, you may probably include the food, rice, peanuts. Biodiversity can help us understand our life, our plant lives better. Hundreds of species help feed human. During the 1970s, plant disease wipe out much of the corn crop in the United Nations. During the 1970s, the plant breeder discovered a small population of white corn called maize growing in Mexico. By crossbreeding with the white plants and other plants has been used to produce a disease-free biodiversity. Crossbreeding with white plants has also been used to produce disease-resistant wheat and strain of rice. Biodiversity are made from wood. Biodiversity provide people with useful materials, furnitures, buildings are made from wood. Bamboos, fiber, cotton, flax, and wool. These wools are woven into clothing. Most of the medicines that are used today originally came from white plants. Including those shown in figure 3. Why is biodiversity important to people? An extract from the bark of the Pacific yew was traditionally used to treat arthritis. And rheumatism. It is not known that the bark contains taxol, which is a treatment for some types of cancer. Maintaining stability. Forests usually contain different types of plants. If one type of plant disappears, The forest still exists. Biodiversity allows for stability in an ecosystem. A loss of biodiversity can weaken an ecosystem. Consider what might happen if a disease infects one grapevine in a vineyard. The vines grow close together. Soon, and a disease would come easily from one plant to the next. Soon, the entire vineyard could be infected. Most farmers and gardeners have found that planting alternate rows of different crops can help prevent diseases and reduce or eliminate the need for pesticides. Disease has spread from one vineyard to another. Analyzing data for biodiversity. Example problem. Temperate rainforests, ecosystem in Alaska and California, which has the higher mammal and bird biodiversity. What reduces biodiversity? Flocks of thousands of messages. Pigeons used to fly. The passenger's pigeon has been extinct for almost 100 years. An extinct species is a species that once exists on Earth but has died out. Earth science integration. Extinction can be caused by competition from other the extinction shown on the graph occurred in the extinction shown from the graph occurred in Mesozoic era. This event course might have caused climate changes. Of the suddenly empty environment. After the dinosaur disappears, many new species of mammal appeared on Earth. Not everyone agrees about the reason for the extinctions of dinosaurs. One thing is clear: human action had nothing to do with dinosaurs. Dinosaurs were extinct millions of years ago, before humans were on Earth. Today, it is different. It is estimated that 100, if not 1,000, of tropical species became extinct during the same year, 20 years period. Human activities probably contributed to the extinction. As the human population grows, many more species could be lost. Endangered species. To help prevent extinction, it is important to identify species that could soon disappear. A species in danger of becoming extinct. For centuries, humans have considered rhinoceros horn. One has considered shown if Rhinoceros are plant eaters. They use their horn to battle each other for territories. They hunt. For centuries, humans have considered rhinoceros horn a rare treasure. It is so though selling rhinoceros even though selling rhinoceros horn is against international law. In 1970, about 1,000 black rhinoceros in Africa. In the year 2000, fewer than 3,000 live. Threatened species. If a species if a species is likely to become endangered, it is classified as a threatened species. It is classified as a threatened species. If the species is free, it is classified as a free species. Now, it is likely to become endangered in future. The Australian people realized that a koala bear was endangered. What shown in figure 8 is threatened. People once hunted koalas for their fur. In the 1930s, people realized that the koala were in danger. And the koalas began to go extinct. By the year 2000, nearly two-thirds of the koala habitat had been lost to logging, agriculture, cities, and roads. The African black rhinoceros is an endangered species, partly because people continued killing these animals for their own. As the map shows, this species once lived for many years. Koalas are related to kangaroos and option. The loss of their habitat threatened the future wide koala's population. Habitat loss. In the explorer activities at the beginning of this chapter, you probably observe the lawns or pavements of the habitat species may become lost. Biodiversity might reduce. Adult snake biodiversity might reduce. Habitat loss is a major reason why species go extinct. Or endangered. As shown in figure 9, or extinct. The Lake Erie water snake is classified as a threatened species because of habitat loss. This snake live long. They live along the shore of rocky shore of island in Lake Erie. The island are popular recreation spots. The development of boats, docks, and in the area building in the area has seriously reduced the amount of habitat available to the snake. Also, these snakes are often killed by people who mistakenly think they are poisonous. They can bite, however, they have sharp teeth, but they are not dangerous to human, especially if left on. Conservation strategies for protecting the lake should be noted. Snakes include protecting the Lake Erie water by limiting development in some areas. Also, as a public education program has been developed to inform people about this predator species and its importance in the lake ecosystem. The Lake Erie water snake has become a threatened species. The building of boat dock, roads, and shopping center is reducing the snake habitat. Banana. This snake are not dangerous to human, but many are killed by people who fear snakes. Divided habitats. Biodiversity can be reduced when habitat is divided by road, city, farm, small patches of habitat, If their habitats have less biodiversity, then biodiversity than large areas. One reason for this is one reason for this could be that large animals like mountain lions and grizzly bear requires hunting territories. Suppose a fire destroys part of the forest and all the salamanders living there are destroyed. Later, after new trees have grown, but what if fire destroys a grove? Of trees surrounded by parking lots and buildings, trees and salamander perish. Trees might grow back, but the salamanders might never. Because none live in nearby paved area. Introduce species when species are needed to be introduced. Often have no competitor. They can have a dramatic effect on biodiversity. And introduce species move into action and have no competitor or predator in the new area of their action. Native species are the original organisms in an ecosystem. In early 1800s, European settlers brought goats with them to Santa Catalina Island off the coast of California. The goats overgrazed the land, completely eliminating 48 of the native plant species and exposing patches of bare soil. Strong. The bare soil provided a place for hardy the weak ground We graded out species after goats were removed from the island. Some native plants species began to recover. Figure 11 shows introduced species that have biodiversity in their ecosystem. Biodiversity is also affected by pollution of land. Water or air, soil that is contaminated with oil, chemicals, or other pollutants. Because any reduction in plant growth can limit biodiversity. Water-dwelling organisms are easily harmed by pesticides, chemical oil, and other pollutants that contaminate the water. Water pollutants often come from factory ships, this water usually flow untreated into nearby waterways. Storm drains should never be used to dispose of used motor oil, paint, solvents, or other liquid wastes. These pollutants can kill aquatic animals, plants, fish, frogs, air pollutants. A form of air pollution, a form of water pollution known as acid rain is caused by air pollution. Acid rain forms when sulfur dioxide and nitrogen oxide released by industries and automobiles combined with water vapor in the air. As figure 12 shows, acid rain can have serious effects on trees. It washes calcium and other nutrients from the soil, making the soil less feather. One tree species that is particularly vulnerable to acid rain is the sugar maple. Many sugar maple trees in New England and New York have suffered major damage from acid rain. Acid rain also harms fish and other organisms that live in lake and stream. Some lakes in Canada have become so acidic that they have lost almost all their fish species. In the United States, 14 eastern states have acid rain level high enough to harm aquatic life. Air pollution from factories, power plants, and automobiles can harm sensitive issues of many organisms. For example, air pollution can damage the leaves or needles of some trees. Some lakes in Canada have become so acidic that they have lost almost all their fish species. In the United States, 14 eastern states have acid rain level high enough to harm aquatic life. Air pollution from factories, power plants, and automobiles can harm sensitive tissues of many organisms. For example, air pollution can weaken and damage the environment and ecosystem. Trees, this can weaken them and lead to trees less able to survive disease, attacked by animal, pests, or environmental stress, such as drought or flooding. Global warming. Global warming, earth integration, overexposure to the sun radiation can cause health problems such as cataract, which cloud the lens of the eyes, and skin cancer. In your science journal, describe ways to limit your exposure to the sun damaging radiation. Global warming. Carbon dioxide, carbon 202, is released into the atmosphere when coal, wood, gas, or any other fuel is burned. People burn fuel. People burn fuel People burn large amounts of fuel, and this is contributing to an increase in the atmosphere This is contributing to an increase in the percentage of carbon 2 in the atmosphere. An increase in carbon 2 could raise Earth's average temperature. Global warming might lead to climate changes that could affect biodiversity. For example, portions of the polar ice cap could melt, causing flood in coastal ecosystem. Around the world, ozone depletion. The atmosphere include in the ozone layer, which protects life on Earth from the sun. Harmful ultraviolet radiation. The ozone layer consists of ozone gas, and is about 15 kilometer to 30 kilometer above Earth's surface. The ozone layer prevents damaging amounts of ultraviolet radiation from reaching Earth's surface. Scientists has discovered that the ozone layer is becoming thinner. And The thinning of the ozone layer is called ozone depletion. This depletion allows increased amounts of ultraviolet radiation that can harm living organisms to reach Earth. For example, for 10% since the 1970s, you probably have seen videos of waterbeds covered with an oil spill. Nearly 4 billion kilograms. But as you find out in these activities, what you instigate, how difficult it is for you. This bed depends on it can coat the feathers of waterbed. This bed depend on their futures of insulation from the cold. Oil feathers lose their insulating qualities. So oil beds are exposed to the cold. Oil-coated feathers are also oil-coated feathers also prevent the birds from flying and can cause them to drown. Rescue team try to clean off the oils, but as you find out in these activities, this is a difficult task. What you investigate, goal. The goal, experiment with different methods for cleaning oil from bird feathers. Experiment with materials. Beakers. Bird feathers. vegetable oils, red, blue, and green food coloring. Green food coloring paper towels. Procedure. Lay paper towel, fill your beaker with vegetable oil, and add several drops of red, blue, and green food coloring. Allowing the excess oil to drip back into the beaker. Lay the feather on the paper towel. 3. Using a paper towel, blot the oil from one feather. Run Run your finger over the feather to determine if the oil is gone. Using the cotton swab, a toothbrush, brush the oil from a third feather. Then check it for oil when you are finished. Use a sponge to clean the fourth feather. Check it for oil when you are finished. Put several drops of dish soap into a beaker. Conclude and why. Put several drops of dish soap into the beaker. And fill the beaker with water. Soak the fifth feather in the solution. Check the feathers for oil after it has soaked for several minutes. Conclude and apply. The method or methods that best removed the oil from the feather. Describe the condition the feathers after you finish cleaning them. Then tell why rescuers would be hesitant to use soap when cleaning live birth. Use how oil pollution affects water mama, such as otters and seals. Conservation biology. Protecting biodiversity. No. Protecting biodiversity. The study of method for protecting biodiversity is called conservation biology. Conservation biologists develop strategies to prevent the continuing loss of members of a species. Conservation strategy must be based on a thorough understanding of the principle of ecology, because human activities are often the reason for why a species is at risk. Conservation plan conservation plans also must take into account the need of the human population. The need of the human population and of other species often conflict. It can be difficult to develop conservation plans that satisfy both. Conservation biologists must consider laws, politics, society, and economics, as well as ecology. Walkie-talkie, Miss Road. Thank you so much. The Florida manatee is an endangered species. Mantles are plant-eating mammals that live in shallow water along with the coast of Florida. And Carolinas. These animals swim slowly, occasionally rising to the surface to breathe. They swim below the surface but not deep enough to avoid the propellers of power boats. Many manthes have been injured or killed. By power boats propellers. Boaters cannot always tell when manthes are nearby, and it is difficult to enforce speed limits to protect the manatees. Also, the manatees' habitats I'm here, and I'm looking for spelling. Is being affected by Florida growing human population. More boats are docks who are being built, which can add to the numbers of boats in the water. Water pollution from road and coastal city is also a problem. In the late 1960s, the American bald eagle were listed as the American bald eagles were listed as endangered, so conservation plan were put in place by 1960s. Their numbers had increased, so they were moved to the threatened species list. Conservation biology at work. Almost every conservation plan has two goals. The first goal is to protect the species habitats. Several conservation strategies can be used to meet these goals. Legal protections. Laws can be passed to help protect a species and its habitat. In the early 1970s, people became more concerned that about the number of species. that are going extinct. And in the United States, in response to this concern, the law, the U.S. Endangered Species Act of 1973, became a law. This act makes it illegal to harm, collect, harass, or disturb the habitat of any species on the endangered or threatened species list. Who would harm the species or their habitats? The Endangered Species Act has helped several species, including those shown in Figure 14, recovered from near extinction. From near extinction, the United States and other worldwide have known that endangered species are being monitored, or threatened species, in 1975. In 1975, endangered species and in 1975, endangered species the Convention on International Trade in Endangered Species of Wild Fauna and Flora, known as CITES, came into existence. One of its goals is to protect, preserve, keep, help, and rescue species. Knowing this, endangered species One of the goals is to protect certain species by controlling or preventing international trade in those species or any part of them. About 5,000 animals and 25,000 plant species are protected by this agreement. Habitat preservation, even if by law it cannot survive unless its habitat is protected. Conservation biology. One way to do this is to create nature preserves, such as national park and protected wildlife areas. Corridors. Are strategy for endangered species. The United States established its first national park, Yellowstone National Park, in 1872. At that time, large animals like grizzly bears, elks, and moose range over North America. These animals roam across large areas of land in search of food. If their habitat becomes if their habitat becomes too small, they cannot survive. Without national parks and wide areas, some animals will be far fewer and in between. Without wildlife corridors, Yellowstone National Park. Yellowstone National Park contains many volcanic features such as geysers, hot springs, and more volcanoes. The land surrounding these features research what the National Park Service has done to preserve this fragile environment. To your class, what you learn. Some wildlife corridors allows animals to pass safely under roads and highways. These maps, somebody should collect that thing from Ramfire. This map shows the type of habitats where most population of Florida panther are found. Notice the major highway that cross these areas. I blame chicken. Wildlife corridor. The successful conservation of a species like the grizzly bear requires enormous amounts of land. However, it is not always possible to create large nature preserves. One alternative is to link smaller parks together with wildlife corridors. Wildlife corridors allows a species like the grizzly bear requires enormous amount of land. However, it is not always possible to create that amount of land. So, however, one alternative is to link smaller parks together with wide corridors. Now, wildlife corridors allows animals to move from one preserve to another without having to cross road, farm, or the other areas inhabited by humans. As figure 15 shows, wildlife corridors are part of the strategy for saving
biodiversity from one preserve to another without having to cross road, farms, or other areas inhabited by humans. Just shut the fuck up, Raphael. A figure 15 shows wildlife corridor are part of the strategy for saving the endangered Florida panther. A male panther need a territory of 17 kilometers square or more, which is which is which is which is saving the endangered Florida panther. A male panther needs a territory 712 kilometers square or more, which is larger than many of the protected panther habitats. Habitat restoration. Habitats that have been changed or harmed by human activities often can be restored. Habitat restoration is the process of taking actions to bring damaged habitat back to a healthy condition. This one stay forever. Okay. Back to a healthy condition. Rhode Island Narragansett Bay was once an important fishing area. It supported populations, flounders, bay scallop, blue crab, and other important food species. Airgrass, which is an open wildlife area. Habitat restoration and habitation in the hope is supported which is an underwater plant that grows in important plant that grows in shallow parts of the bay. For the young of many of these species, as the human population of Rhode Island grew, most of the bay airgrass bed disappears
Fish and shellfish population declines. People who live in the area knew that something needed to be done. Students in Rhode Island schools have been have helped restore dead grass habitats by growing thousands of egg grass seedlings for transplanting into the air bay as shown in figure 16. When is habitat restoration? Wildlife management. Preserving or restoring a habitat does not mean that all the species living there are automatically protected from harm. In South Africa, guard patrols wildlife park to prevent park poachers. Poachers from killing elephants. To prevent such poachers from killing elephants. For limiting the numbers of visitors allowed to see them. The gorillas. The gorillas of Rwanda by wildfire preserve allow no visitors other than biologists who are studying the area. Hunters and wildlife managers work together to maintain a healthy ecosystem. It also helps protect population from overhunting. For example, license may limit the number of animals a hunter is allowed to take, or may permit hunting only during hunting seasons. When a species is not reproducing, for example, regulation also can give help prevent a population from becoming too large for the area. By restoring airgrass habitats. The Arabian ox was saved from extinction. Captive population. The Arabian ox, shown in figure 17, is native to desert lands and the Arabian Peninsula. People hunt, but they can't hunt for its own and hide. Hunting increased during the 20th century. When four-wheel drive vehicle became available to hunt. In 1962, to prevent the species from becoming extinct, several owls were taken to the Phoenix Zoo in Arizona. But by 1972, no more wild owls lived in the desert. A captive population. Is a population of organisms that is cared for by humans. The captive population of owls in Arizona did well. Their numbers increased, and hundreds of Arabian owls now live in zoos all over the world. Their number, keeping endangered or threatened animals in captivity, can help preserve biodiversity. It is not ideal. However, it can be expensive to provide proper food. Also, captive return to their natural state. What warning? The captive population was in Arizona did well. Now, their numbers increase, and hundreds of Arabian owls now live in zoos all over the world. It can be expensive. to provide proper food, adequate space, and the right kind of care. The best approach is to preserve the natural habitat of these organisms so that they can survive on their own. Reintroduction program. In some cases,
If you wear walkie-talkie, you understand.
in some cases, members of captive population can be released into the wild to help restore biodiversity. Where are the species, where programs like this can succeed only if the factor that caused the species to become endangered are removed. Small branches were cut from these trees and rooted in soil. By 1850, Saint Helena ebony was the thought on the thought in the, on the thought that the home was to be rare. Settlers also cut trees for firewood. This saints, this saints, European settlers introduced goats to the island. Goats overgrazed the land, and native trees were replaced by introduced species. In 1980, two small ebony trees were found on the island. High on the cliff, these cuttings have been used to grow thousands of new ebony trees. These cuttings have been used to grow thousands of new ebony trees. But the new trees are being replanted all over the island. Sea banks. Throughout the world, seed banks have been created to store the seed of many endangered plant species. If any of these species come extinct in the wild, the stored seed can be used to introduce them to their original habitat. Relocation. Reintroduction programs. Do not always involve captive population. The brown pelicans shown in figure 18 the brown pelicans shown in figure 18 were once common along the shores of the Gulf of Mexico. In that era, pelicans eat fish that eat aquatic plants. In the mid-20th century, it eventually ended before the chicks entered. In 1971, 50 of these birds were taken from Florida to Louisiana. Since then, the population has grown. In the year 2000, more than 70,000 brown pelicans lived in Louisiana and Texas. Brown pelicans from Florida were relocated successfully to Louisiana. What are the differences between ecology and conservation biology? How does the U.S. Endangered Species Act protect species? What are the differences between ecology and conservation biology? Why do most conservation Chicky, please collect that walkie-talkie from Ramfire. Why do most conservation plan include habitat preservation strategies? What factors can sometimes make it difficult
to introduce captive animals into their natural habitat. Think critically. As a conservation biologist, you are helping to restore egress bed in Narragansett Bay. What information will you need to prepare skill builders activities? Biodiversity and health of a plant community. Some plant diseases are carried from plant to plant by specific insects, and they can spread quickly throughout the garden. If a garden only has plants that are susceptible to one of these diseases, the entire garden can be killed. When an infection occurs, one of these diseases is the entire garden can be killed when an infection occurs. Can infect impatiens and other garden plants. Throughout the garden, if a garden only has plants, if a garden only has plants, they are susceptible to one of these diseases. The entire garden can be killed when an infection occurs. When an infection occurs, could biodiversity help prevent the spread of necrotic leaf spots, a stimulation can help you answer this question? Now, what you investigate once on a piece of white paper, what you investigate is
How does biodiversity affect the spread of a plant disease? Materials: plain white paper, colored paper, orange, yellow, green, black, red dye. Goals: record data. Two, compare the spread of disease in communities with different levels of biodiversity. Predict a way to increase a crop harvest. Safety precaution. Use care when cutting with the scissors. On a piece of white paper, draw a square that measures 10 centimeters. Draw a square that measures 10 on each side. This represents a feed in the square. Make a grid with 5 equal rows and 5 equal columns as shown. Number the outer cell from 1 through 16 as shown. The inner cells are not numbered. Cut 1.5 centimeter times 1.5 centimeter tile. The other column represents different plant species. Now, for example, all the red thigh represents one plant species. All the blue thigh are another species. And the blue thigh and each remaining color is a different species. There are 4 rounds in this. There are 4 rounds in this stimulation. Roll the die once for each square. proceeding from square 1 to square 2, and so on through square 16. High biodiversity. Distribute 5 red, 5 orange, 5 yellow, 5 green, and 5 blue plants in the world. Round 1, high biodiversity. Two, moderate biodiversity. Distribute 10 orange, 10 yellow, and 5 green plants in the field. Round 3, low biodiversity. Moderate biodiversity. Distribute 10 orange, 10 green, 10 yellow, and 5 blue biodiversity. If 2 plants, I am going for my break, a short break. No, they go carry this there, don't soak. I'm good. I'm good now. Hello, 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 hello.
Today one is better.
Student resources. Biomes. Technology school ski handbook. Using graphics. Event chain. Cycle map. Researching information. Biomass. Tundra. Winter in the tundra are long and harsh, and summers are short. There is little precipitation in the tundra. You find moors, lynches, grass, and Arctic fossils, Arctic hares, snowy owls, and hawk. Taiga. Winters in the taiga are cold and severe with much snow. Growing seasons are short. Conifers such as spruces, firs and lashes are common in the taiga. You find caribou, wolves, moose, bears, ducks, loons, owls, and other birds. Temperate deciduous forests. The temperate deciduous forest has cold winters, hot summer, and moderate precipitation. You can see the trees in a temperate deciduous forest. You can see the trees such as oaks, hickory, and beech, which lose their leaves every summer, every autumn. Wolves there, bear, bear, which lose bears, small mammals, and birds are common in a temperate deciduous forest. Temperate rain forest. Grace we need to make good success. The summers and the winters in the temperate rainforest Rarely a myth. Temperature rarely falls below freezing. The temperate rainforest has heavy participation. Deserts are warm to hot in the daytime. Small rodent jackrabbits, bird of prey, because of Facebook. Bird of prey, sharp object. And snakes makes their home in the desert. Oh God. Makes their home in the desert. Yeah. Tropical forests. Tropical forest the tropical rainforest is hot all year. With great diversity. I'll press it well. Plant species grow in tropical rainforests. And also, it provides homes for birds, reptiles, insects, monkey, and slugs. In the tropical rainforest, yes, sir. In the tropical rainforest, there are a lot of animals taken care of. Temperate rainforests, deserts, waste management. Paper, white paper, magazines, telephone, books are common in the rainforest. Now, newspaper, magazines, white papers, and telephone books are common paper goods that can be recycled. New products made from this item include newsprint, cardboard, egg cartons, and the likes. Even building materials. Not all glossy and colored paper are recyclable at recycling centers. Recycle your local recycling center for specific instruction about properly sorting your paper goods. Plastics. Plastics are difficult products to recycle. Most plastics are composed of complex molecules that tend not to break down easily. Many types of plastic exist, and they often cannot be recycled together. List the code that are used to sort plastic items for recycling. Plastic is recycled into number, containers, carpets, and other products. The plastic code system. Glass. Glass often open is separated by color, before recycling. Some glass bottles, such as light bulbs, is too thin to be recycled. New products made from recycled glass include food and beverages container, plastics, metals, a variety of metal, are recyclable. Steel is the most common material recycled in the United States. Steel is recycled into any item new steel would be used for such as food cans, structural beams for building, and parts for automobiles. Aluminum is a commonly recycled material. It is recycled into new beverage, can, lawn chairs, frames, siding, and cookware. Even previous material Even previous material. Recycling still saves enough energy to supply to supply one-fifth of the household in the United States. Electricity for 1 year. A recycled aluminum beverage can use 95% less energy to produce than a can made from new aluminum, which is enough energy born which is enough energy born 100 worth 3.5 hours. Organic waste. Organic waste such as yard trimmings and waste paper and wood make up a large percentage of solid waste in the United States. Food and yard waste can be placed in compost bins and converted into nutrient-rich soil. Mulching in another way to recycle yard waste and wood. In some communities, grass clippings, leaves, sticks, and other yard waste can be shredded at local recycling centers. To make mulch. Mulch is used to reduce water loss from soil and to keep weed from growing. As the mulch decays, it enriches the soil. Household hazardous waste. Household cleaners, paint thinners, motor oil, gasoline, are marked with skulls and crossbows. Caution: they are contained chemicals that can cause injury or are harmful if used, stored, or discarded improperly. HHWS are marked with skull and crossbones. HHWS should not be sent with other garbage fillings. Or burning may send toxin into the air while we breathe. Garbage companies and recycling agencies have free HHW drop-off day allocation. Follow these steps to reduce household hazardous waste. Organizing information. As you study science, you make many observations and conduct many researches. The quality of the data you collect and the way you organize it putting your observation in writing is an important information you have found and the results of your investigations and your experiments. Researching information. Researching information. Scientists work to build and add to human knowledge. Now, before moving into a new direction, it is important to gather information that already is known about subjects. One, determine exactly what you need to know about the subjects. For instance, you might want to find out what happened to the local plant when Mount St. Helens erupted in 1980. Step 2. Make a list of questions such as: when did the eruption begin? How long did it last? How long was the area in which plant life was affected? Use multiple sources such as textbook, encyclopedias, government documents, professional journals, science, magazines, and the internet. List where you found the sources. Make sure the sources you use are reliable and the most current available. List where you found the sources and making an observation in one way to gather information directly. Evaluating prints and non-prints. Evaluate prints and non-prints. Not all sources of information are reliable. You use you use information for your you use sources you use for information for your information. For example, you might find two websites on digestion. One website contains fat zapping tips written by a company that sells expensive high protein supplements. To help your body eliminate excess fats. The other is a web page on digestion and metabolism, written by well-respected schools. You will choose the second website as the more reliable sources of information. You will choose the second website as the more reliable sources of information. In science, information can change rapidly. Always consult the most current resources. (1985) Source about human genome. As you research, interpreting scientific illustrations. As you research a science topic, you will see drawings, information, diagram, and photograph illustration. You can't see the bones. You can't see easily by yourself. But you can look at the diagram of a whale skeleton as a label. Remember, details more easily. Illustrations also provide examples that clarifies difficult concepts or give additional information. Identity and labels. Most illustrations have a label or a caption. A caption, the illustration provides additional information to better explain it. Can you find the caption or labels in figure 2? Can you explain the caption or label in figure 2. A labeled diagram of the skeletal structure of a blue whale. Most illustrations have a label or a caption, Venn diagram. Although it is not a concept of a map, it is, however, how two subjects compare and contrast. The Venn diagram in figure 3 shows the relationship between two categories of organisms, plants and animals. If you were taking a car trip, such as obtaining your punishment, your nourishment that distinguish one from the other. Concept marking. Concept mapping. If you are taking a car trip, you might take some sort of road map. By using a map, you begin to learn where you are located. A concept map is similar a Venn diagram shows how objects or concepts are alike and how they are different. Plants make their own food stationary. Animals eat plants or other animals move from place to place. Alive, reproduce, grow, and develop. Eukaryotic cell consists of nucleus, cytoplasm, organelles, and cell membrane. Nucleus, organelles, cytoplasm, and cell membrane. Where nucleus controls all activities, an organelles controls An organist controls the organist's activities. Look at the network tree in figure 4. That shows details about the concept of map. Now, notice how some works are in oval, while others are written across connecting line. When constructing a network tree, with the majority of concepts we trust that a lot of things will come out well. The words written the words written the words inside the oval are science terms or concepts. The words written on the connecting lines describe the relationship between the concepts. Then arrange them in order from general to specific, branch. Write the relationship between the concept and the connecting line until all concepts are mapped. Then examine the network trees for relationships that cross branches and add them to the network trees. Event chains. An event chains is another an event okay this is powder an event phase is a type of concept map. It models the order of items or their sequence. In science, an event chain can be used to describe a sequence of events. The steps required to do an event and how to go about the event. When making an event chain, first, suppose you are asked to describe the main stage in the growth of a plant from a seed. You might draw an event chain such as the one in figure 5. Notice that connecting words are not necessary in the chain. Sunshine or swear or soil. Seed is planted and watered. Root begins to grow downward. Shoots begin to shoot upward. Everything keeps going. Roots begin to shoot. Wow. God made sure everything is sorted. Event change shows the order of the step in a process or event. The event chain ensures that everything here is accessible to us. A style concept map. The series of events in this event chain make sure we are good. From one event to the other, look at the circle map in figure 6. Plants undergoing photosynthesis. Plants undergo photosynthesis, but without first completing the cycle map. Spider-Man, a type of concept map that you can use. The circulatory system spider styles map in figure 7 shows that if you write this idea outside the main concept, then you can begin to separate the group until they become skillful and useful. Figure 7. A spider map allows you to list ideas that relate to a central topic, but not because or not necessarily to one another. Writing in paper. You write paper often when researching science. Writing a paper. Investigation. Position your data. You will write paper often when research you write paper often when researching or reporting the results of investigative experiments. Scientists frequently write paper to share their data and conclusions with other scientists and the public. When writing a paper, use this step. Step 1. Assemble your data by using graph, tables, or concept maps. Create an online live. Create an online live. That is step 3. Step 4. Position data to help support your point. Step 5. Summarize the main point and finish with a conclusion. Use tables, graphs, charts, and illustrations whenever possible. Investigating and experimenting. Identifying a question. You might observe that a corner is lower than the surrounding area and has less vegetation growing in it. You might decide to see if planting some grass We keep the corner dry. Scientists use orderly approach to solve the problem. The methods scientists use include identifying a question, making observations, forming an hypothesis, testing an hypothesis, analyzing results, and drawing conclusions. Scientific investigations. Such observation of an object or a process can suggest new and interesting questions about it. These questions sometimes lead to the information of a hypothesis. Scientific investigations are designed to test a hypothesis. Sampling. When working with large numbers of objects or a large population, scientists usually cannot observe or study every ounce or study every one of them. They use a sample or a portion of the total number to sample it to make a small representative portion or organisms. By making careful observations or manipulating variable meaning. Conclusions are drawn that might apply to the whole population. Estimating scientific work also involve estimating. To estimate is to make a judgment about the size or the number of something. Without measuring or counting every object or member of a population. Scientists first count the number of objects in a small sample. Looking through a microscope lens, for example, kilo, hecto, deca, deci, centi, milli. Measuring in SI. The metric system of measurement was developed in 1795. A modern form of the metric system called the international system or SI was adopted in 1960. SI provides standards measurements that all scientists around the world can understand. The metric system is convenient because unit sizes vary by multiples of 10. When changing from smaller units to larger units, the metric system is convenient because unit sizes vary varies. The metric system is convenient when changing from smaller units to larger units. Multiplying by a multiple of 10. To convert milliliters to centimeters, divide the millimeters by 10. That is 30 millimeters divided by 10. Preface. I use for this event for some common metric preface and their meaning. Do you see how the prefix kilo attached to the unit gram in kilogram? Making and using table mass. Scientists measures mass in gram. bar graphs, line graphs, waste management, sampling, investigating and experimenting. Investigating and experimenting. You might say the work of a scientist is that of an investigator. One, you might observe that the corner is lower in the surrounding than the other places. Scientists use orderly approaches to solve problems. Scientists investigations involve careful observation under controlled conditions. You can identify a question making observations, analyzing results, drawing conclusion, testing an hypothesis are all part of the what we are breaking. Scientists know what they want and they go for it. Scientists are not confused. Identifying a question. No poverty. The first step in a scientific investigation or experiment is to identify a question to be answered or a problem to be solved. You might be interested in knowing why an animal like the one in here look the way it does. When you see a bird, you may ask yourself, how does this shape of the bird help it feed? Forming hypothesis. Hypotheses are based on observations. Perhaps a scientist has observed that being plants A hypothesis that has something that we already want. The statement is a hypothesis. Fertilizer makes bean plants grow bigger. A testable hypothesis is a valid hypothesis. When you apply a hypothesis to a specific situation, plants fertilizers, someone could use the prediction to plan to grow fewer plants. Testing a hypothesis. To test a hypothesis, you need a procedure. But then, a procedure is the plan you follow in your experiment, as well as when you follow a procedure, data are generated. The generated data are not in any way helpful. We are trying to stay awake. Our whole investigations are like keep in mind that you notice it as your own surprise. Where is it now? If water temperature increases, not all hypotheses are tested. I don't want. Try for your experiment and generic pass. Are all investigations alike? The skill in this handbook is too much. They've gone. The skill in this book are here for you. After identifying and multiplying variables and control. In any experiment, is important to keep everything plain and neutral. One factor you change is the independent variable. The factor that changes as a result of the independent variable. In my experiment, it is important in all ratification to keep everything the same. Fast forward. It is important to keep everything the same. The one factor you change is called the independent variable. For this, move the independent variable and make sure you have only one independent variable. If you allow more than one, you will not know what causes the change you observe in the independent variable. If you allow more, many experiments also have controls. Individuals, instances, or experimental subjects for which the individual variable is not damaged. You can then compare the test results to the control results. The activity level of the goby was measured as the number of goby movements, the dependent variable. Always make sure you have only one independent variable. The factors that changes as a result of the independent variable is called the dependent variable. Always make sure you have only one dependent variable. If you allow more than one, you will not know what causes the changes you observe in a dependent variable. Many experiments also have control. Individual instances or experimental subjects for which the independent variable is not changed. You can then compare the results to the control results. Oh God. When you apply interested in knowing why an animal, look at this, to the controlled results. For example, the glass containers were identical. The volume of aquarium water in which aquarium was supposed to be didn't come, so there was no aquarium. It is important to keep everything. It is important to keep everything. For example, each copy be like the other as much as possible. In this way. The guppy in the container which water was. Collecting data. Whether you are carrying out an investigation or a short observational experiment, you will collect data or information. Scientists collect data accurately as numbers and description and organize it in specific ways. Observing. Scientists observe items, then record what they see. Making things happen. Making things happen. Scientists' observation can now observe, describe how much there is something. These observations are numbers as well as if a particular dog is described as being furry, yellow, and short-haired. When you make observation in science, you should examine the entire object or situation. First, then, look carefully for details. If you're looking at a plant, for instance, check general characteristics such as size and overall structure before using a hand lens to examine the leaves and other smaller structure such as flower or fruits. Remember, to record accurately everything you see. Scientists try to make careful and accurate observations. Now, measurement provides numerical data that can be repeated and checked. Sampling. When working with large numbers of objects or large objects, scientists usually cannot observe or study every one of you within that short time. So what they do is, instead they use a sample or a portion to alter the number, to sample as if to take a small representative portion of the object or organisms of a population for research. By making careful observations or manipulating variables within a period portion of a group, information is discovered and conclusions are drawn that might apply to the whole world population. Estimating scientific work also involves estimating to estimate 13 to estimate to estimate to estimate 13 or even 14 is shocking. The metric system of measurement was developed in 1795. A modern form of the metric system called the International System, or SI, was adopted in 1960. SI involved standard measurements that scientists use. The SI system is convenient because unit sizes vary by a multiple of 10 when changing from smaller units to larger units, divided by a multiple of 10 when changing from a larger unit to smaller units, multiplied by a multiple of 10 to convert millimeters to centimeters, divide millimeters by 10 to convert 30 millimeters to centimeters, divide 30 by 10 to name units. Look at the table below for some common metric prefix and the meanings. Do you see how the prefix kilo attached to the unit gram is kilogram? Now, look at the metrics. Look at the metrics. Look at the prefix The milli means thousands. Liquid volume. In some science activities, you measure liquids. The unit that is used to measure liquids is the liter. A liter has the volume of 1,000 centimeter cube. The prefix milli means thousands. The millimeter is 1,000th of 1 liter, and 1 liter has the volume of 1,000 milliliter. 1 millimeter of liquid completely fills a cube measuring 1 centimeter on each side. We use beakers and graduated cylinders to measure liquid volume. A graduated cylinder, as illustrated in Figure 12, is marked from bottom to top in millimeters. These graduated cylinders contain 79 millimeters of a liquid. Graduated cylinders measures liquid volume, mass. Scientists measures mass in gram. You might use a beam to balance things similar to this, but when it comes to sharing balance on this, each person had a right before you find the object. Sides of the riders back to 0 points. Check the pointer on the right to make sure it swings an equal balance, an equal distance. If unequal, find and turn the adjusting screw. Place an object on the plan. Object rider, group. Below 0. Then move it back 1 notch. Place an object on the pan. Slide the larger rider along a beam until the pointer drops below 0. Then move it back 1 notch. Sum the mass on each beam to find the mass of the subject. Move all the riders back to 0 when finished. A triple beam balance is used to determine the mass of an object. You should never place a hot object on the palm or pour chemical directly into the palm. Instead, find the mass of a clean container. Using, or rather making and using tables. Browse through your phone and you will see how to make and use tables. Check for data. Check for activities tables. Help organize the data you collected during an activity so results can be interpreted. Making tables. To make a table, list to make a table, list the items that will be listed. They are as follows. One, making table. List the items that can be called. That can be compared in the pair. The table below lists materials. Collected for recycling on 3 weekly pickup days. The inclusion of kilo, using tables, the kilogram in parentheses also identifies for the reader and the inclusion of kilo, the reader that figures out the mass. Using table, how much paper in kilogram is being recycled on Wednesday? The box where the table column and rows are the answer can be put there. Then the interest can also be put there. Then and so How much aluminum in kilogram is being recycled on Friday? You understand how the table is. So, you understand how much glass is collected for recycling each week. Locate the column labeled glass and add the figures for all 3 rows. Answer 32.0. Then you know how to locate us and use the data provided in the table. To be useful, the data you collect must be recorded carefully. Then, record activities of attempts as well as the whatever I will do. The record information. Then us, our know-how. Then record attempt name. Then it is important to note that you can organize your thoughts and organize the observation and other data you collect and record in many ways. Many models is one way to help you understand better the plot of a structure, or is making various measurement reports. Models often show things that are very large, small, or otherwise would be large to see that it looks nice. You can study blood vessels and know that they are all tubes. Their size and proportioned different. Ready, sure. Record information properly and neatly. Never put unidentified data on scrap. Making and using graphs. After science observation, after science observation of using graphs in data and table, they might display. Next thing they will bring, normally we need to bring a system next. The next thing they will bring first is that another curve makes interpretation and analysis of data easier. 3 types of graphs are the lines graphs, bar graphs, cycle graphs. Line graphs, like in figure 15, is used to show the relationship between
two variables. The variable being compared to go on two axes of the graph. For data from an experiment, the independent variable always goes on the horizontal axis called the x-axis. The dependent variable always goes on the vertical axis called the v-axis. When I've already said it, I started posting. Called the x-axis. Independent variable. The dependent variable always goes on to first. Oh, that's right. Circle the years after making your ass. Label each with scale. Next, put a point in the intersection of the recorded value of the dependent variable for effect of temperature on virus and on production. The line graph shows the relationship between body temperature and the many infecting viruses present today in our body. Analyzing results. Bar graphs. Bar graphs compare data that do not change bar graphs. Bar graphs are data that get the data. Scientists use data to understand what should be said as it is being said. We are to observe, divide data, and know how it is moving.
Biodata
Should be made known to our directives. Biodata is something we should follow and understand. Scientists use several approaches to analyze data
The data they've collected, each approach is useful for communication. So the bi-data approach should be given to us before it is given to the public. Bi-data still is available, but forms only operational definition for now in Benin. An operational defines an object or something before you're calling for the price. So, your line graph should be worked on. Data point of entry as well as the point of recovery should be known. So, line graph is, by our own definition, ready for us. Line graph forming operational definitions, and operational define objects by showing how it functions. Bi-data was given to the public so our bi-data is removed yes. So, analyzing results. If we analyze results simultaneously, if it is results, similarly know better, best, by our imagination, we know that we can be doing what we are doing, but it is better if what we are doing is easily transmitted. Or what do you think they're over there, kids? So please, Raphael is now listening on it. It's recording for truth. Yeah. Now.
An operational definition defines objects by moving an operational definition defines an object by showing how its function works or behaves. Such definitions are written in terms of how an object works, can be used. That is, they describe its job or purpose. For example, a picture where a ruler also can be defined as something created a series of marks. It's a standard measuring as a standard measuring common features when classifying. First, observe we are moving. How to identify a group's mind. Amen. And if anyone is nobody. Egg. Lizard. Cockroach. Pen. Story. Iwo. Egg. Lizard. Pen. Cockroach. Story. Iwo. We could then look for another common feature. My wish to bring everyone in the group together. So I already came here for our Christmas carol and there was nobody on ground. So I told them I wanted to give them surprise visits. Nobody's on ground. I'm leaving. I'm just analyzing results. I don't hear what I'm doing here. So I'm whining from here first to here.
No, go relax.
Remember, I'll finish that one now. That when you classify, you are grouping objects or events for a purpose. For example, classifying animals. You can be the first example. And also be thread.
but the bed wait. Would you wear clothes to find it in a man or to find it in a woman? You will locate a cardinal within a woman.
Where the cardinal?
You will locate.
Where the woman?
You will locate a cardinal. Okay, within the red grouping of birds that you separate from the rest of the animal. A male ruby-throated hummingbird could be located within the bed by its tiny size and the bright red color of his throat. Keep your purpose in mind as you select the features to form groups and subgroups. Not always easy, so we'll keep going. Comparing and contrasting. Observations can be analyzed by noting the similarities and differences between two or more objects or events that you observe. When you look at objects or events to see how they are similar, you are comparing them. Contrasting is looking for differences in objects or events. The table below compare and contrast the nutritional value of two cereals. Now, recognizing cause and effect. Have you gotten a cold? And then suggested that you probably caught it from a classmate who had one recently. If so, have you observed an effect and interred a cause? The event is the effect, and the reason for the event is the cause. When scientists are unsure of the cause of a certain event, they design controlled experiments to determine what caused it. Interpreting data. The word interpret means to explain the meaning of something. Look at the problem originally being explored in an experiment and figure out what the data show. Identify the control group and the test group so you can see whether or not changes in the independent variable have had an effect. Look for differences in the independent variable between the control and the test group. These differences you observe can be qualitative or quantitative. You would be able to measure a quantitative differences and describe it using numbers. If there are qualitative or quantitative differences, the independent variable that is being tested could have had an effect. If no qualitative or quantitative differences are found between the control and test group, the variable that is being tested apparently had no effect.
For example, suppose that 3 pepper plants are placed in a garden and 2 of them are fertilized, but the third is left to grow without fertilizer. Suppose you are then asked to describe any differences in the plants after 2 weeks. A quantitative difference might be the appearance of brighter green leaf on fertilized plants, but not on the unfertilized plants. A quantitative difference might be a difference in the height of the plants or the numbers of flowers on them. Inferring. Scientists often make inference based on their observations. An inference is an attempt to explain or interpret observations or to indicate what caused what you observed. An inference is a type of conclusion. When making an inference, be certain to use accurate data and accurately describe observations. Analyze all of the data that you have collected, then, based on everything you know, explain or interpret what you have observed. Drawing conclusions. When scientists have analyzed your data, the data they've collected, they proceed to draw conclusions about what the data mean. These conclusions are sometimes stated using words similar to those found in a hypothesis form earlier in the process. Conclusions. To analyze your data, you must review all the observations and the measurements that you made and recorded. Recheck all data for accuracy. After your data are rechecked and organized, you are most ready to draw a conclusion, such as plants need sunlight in order to grow, before you can draw a conclusion. However, you must determine whether the data allow you to come to a conclusion that support a hypothesis. Sometimes that will be the case, other times it will not. If your data do not support a hypothesis, it does not mean that the hypothesis is wrong. It means only that the results and the investigation did not support each other. Now, it is simply to have 1+ malaria, take your vitamins, make sure you're okay. After this, treat yourself. What are your big people looking at me? Experiments need to be redesigned. But very likely, some of the initial observations on which the hypothesis was based were incomplete or biased. Perhaps somebody actually placed something there. Yeah. We're based on we're incomplete or biased. The more the operations was needed,
Who needed to subsist? The more the occupation was applied and done, don't just come and drop the people work and say you need it. You do it. No. You believe it, it's true. Research is needed to define the hypothesis, avoiding bias. Sometimes, drawing a conclusion involves making treatments, making judgments. When you make a judgment, you form an opinion about what your judgment means. It is important to be honest with every judgment. All the time. For example, why pushing a church? And also, evaluating other data and conclusions. Sometimes scientists have to use data that they did not collect themselves, or they have to rely on observations and conclusions drawn by other researchers. In cases such as these, the data must be evaluated carefully. How were the data obtained? How was the investigation done? Has it been duplicated by other researchers? Did you come up with the same results? Look at the conclusion as well. Would you reach the same conclusion from the results? Is it true and you feel comfortable using technology communicating? The communication and feedback I didn't get from those students is an important part of the work of history. It's part of Guinness. The communication The communication of ideas is an important feature of ideas. Feedback is an important feature of ideas on each and every member of this thing. Has it been duplicated by other researchers? Did they come up with the same results? Look at the conclusion as well as the reach. Only when you have confidence in that data of others can you believe it and feel comfortable using it. The communication of ideas is an important part of the work of science. A discovery that is not reported will not advance to the scientific community. Understanding or knowledge
communicates among the scientists. Also, is important as a way of improving their investigations. Scientists communicate in many ways, from writing articles, journals, and magazines that explain their investigations and experiments, to announcing important discoveries on television, radio, sharing, and even finish.
All right.
When I'm done, scientists communicate in many areas and ways. Investigation, improving their indigenization.
Okay. Fala.
Now, no. Scientists communicate in many ways, from writing articles in journals and magazines that examine investigations and experiments, to announcing discoveries on television and radio, to sharing ideas with colleagues on the internet or presenting them as a lecture. People who study science on this relies on what program to make dives on the table. You can use computer program to make dives on the table.
Okay.
Using what, Professor? Using what processor? Assigning written reports. So as you complete your research, a computer application that allows you the type of information. You can change it as many times as you need to, and then print it out so it looks neat and clean and it's not a word processing application. You can use this type of application. We create names, columns, bullets, or cartons, or app for you, a page, include followers or numbers.
Okay.
for spelling. Helpful hints. Five applications. In my opinion, I want to start preparing for my much needed and you can use a computer system to skyrocket. Come move. Now, when it comes to representing the country, that's why I did that before. Already I have a buff of people that I'm looking up to. And I have someone, and I just have no option. I gotta make him. Avoiding bias.
You can do it.
Avoiding bias. Avoiding bias. Sentimental issues. Evaluating chairman, president, current president of the Fisheries Association of Fisheries Students, Lagos State Chapter. And the 5 minutes. Avoiding the bias before then is going to be hard. So you just keep evaluating the video. Sometimes you have to lose your data so it correspond with the data. Yes.
Voters.
So, read about the life of a mariner, life of a seafarer. And sometimes scientists have to provide data for what seafaring are you talking about. Is The one who God has been using to cast him countless times. That this and that. So, but now, he lived in terrain. Scientists often make interference based on their observation as an attempt to explain, observe, or try to indicate. So, in that manner, drawing and having conclusions. In conclusion, to analyze your glorious into the Guinness, you would do it. Well, your data can do anything. Before, he said he would do it, but now he did it. Well, so he didn't move. He kept observing. But now, he has met 2 or 3, 4 people. But now, has brought the record from where it was. Before you can drive a conclusion, have you moved it? Have you understand? Do you know? That the hypothesis well, it only means that she will do it. If your data do not support a hypothesis, then you're not ready to do it. But now, the data supporting the hypothesis. The data supporting the hypothesis. Wow. As it is. We are going to say that we believe in God. We believe in God. I believe in God. I believe in God.
Take me there, girl. Take me there.
I believe in God. I believe in God.
Power. Okay.
I believe in God.
Thou shalt not sleep.
I believe in God. Sometimes students do not know how to go about this. Other time, they do not understand
We are with you.
that it is already ongoing. To analyze the data, communications of ideas is an important part of the record. So, scientist communication is ongoing. But then, it is not advantageous for her, but then or knowledge communication among scientists also.
Go on.
And also, she said, but then, it is as we have said it.
Okay.
Scientists communicate in many ways, from writing to reading, and to also emphasize on it. communication to the world. Using a word processor. Simple when they look, so you can get energy. Using a word processor. Suppose your teacher has assigned you 348 to wait. What would I do? I'll wait. So that is what I will do to you. Wait till we get it right this time. And this time, we'll get it right. Using a word processor. Doing a data research.
We talked about this one before.
That's the only thing that you need me not to sleep now with her.
My time is.
Doing a data research.
You're not communicating.
Doing a data research when searching for information in a database, we use the following search strategies to get the best results. But in as much as we are getting the best results, we are also pushing. We place the word between two people. We place it at the same place we place the former. Forks and mints would give you information to that regard.
Your break is due. Your break is
It's
due.
not you. It's 20 minutes. Please, the word or between two words. If you want the database to show entries that have at least one of the words, for example, forks or mint, would show you information that mention either forks or mint. Place the word not between two words. If you want the database to show, to look for entries that have first words but do not have second words. That is why I told you the forks or the mint. Place the group of forks on your hands. The remaining and the deferment of it will come. But until then, I can grant interviews when I'm done. Using an electronic spreadsheet. Using an electronic spreadsheet. We will be using an electronic spreadsheet during this attempt, as it will be able to buy us time for sleep. So, your science war experiment has produced lots of numbers. How do you keep track of them all? The data and how you can easily
Don't look at time.
easily you can use a computer to work a spreadsheet and to drop it. A spreadsheet is an electronic mathematics worksheet. Helpful hints. Before you set up a spreadsheet, you will identify how to organize, analyze data. So, using computerized card catalog, use graphics. Using technology, skill handbook. Technology, skilled handbook, using graphics software. Helpful hints. Figure 2.1 graphics software. Can we use your data to draw circle graph? Helpful hints. As with any method of having, the most practiced using graphics software by stats. No more. Figure 22. Multimedia presentation. Non-germinated maize beans. Germinated maize beans. As you think on the drawing, as you work on the drawing to acquire the drawing. As you go on the drawing, maybe you could start an outlook, a vision, make sure the representation is well represented. Even if helpful hints carefully tomorrow, we won't do anything but make sure you use impact services using graphics software. Are you having trouble finding text that you shouldn't have issues in? But then graphics will just come out. Maths, skills, management. Use this math skills handbook to help solve problems you have been given in this test. You might find it helpful to review tropicals. But then, how have you thought about things like that? You then think about how the movement is going to affect the man and inconvenience you. So, for inclusivity, we have thereby decided that with the best of our ability, none will be left. After you find the greatest common factors, you can write a fraction in it.
simplest form. Divide both sides by the denominator, and the denominator is refusing to divide. Always not do Asein Angel. We are doing it by the great common factor. The number that results in the fraction is the simplest form. But so converting this is then not converted to the man, because I know, yes, I'll be going on a short break.